Okay, so in traditional database, this is our tradition. This is the front end. Let's assume this is the front end. This is our back end, and there will be a database. This is our, and all of them are connected in a bidimensional fashion. Like it will go like this, and then the data will also come out like this. Okay. Now, what will happen over here is that everything is like front end is controlled by the front end guy, back end is controlled by the back end guy, database is controlled by the database guy. Everyone has their own mind, right? In blockchain, what we are doing is that there are certain, these are called miners. Okay, there are many blocks like this, and all of them are, let's say, connected with instance self. Okay. So as you can see, this forms a network. This forms a sort of intranet, a connected network amongst all the miners. What is miner? Miner is nothing but another desktop. Okay, where your so blockchain, so database right now for our case, like in a previous project, we have used MongoDB. So MongoDB is a database which is hosted with MongoDB company, right? So if tomorrow MongoDB company wants to shut down, we will be losing all our data. We cannot do anything. We have to again, either they will give us some time that okay, take our data and we are stopping our company from that particular day, store your data, put it in some other database. So we are completely on their mercy because you are using a third party tool like MongoDB in our case for storing our data. So this is a hassle, right? We have to wait for them when they are closing their business. That okay, we need to take our backup. Otherwise, if they do not give us that time, our data is gone. As simple as that. We cannot do anything, right? That is why either you have to run the database entirely in your local host or in your controlled server, which is in your control, or there is no other option, or you have to rely on their stuff. So that is where this blockchain comes in. This is the concept of centralization, where something is centralized either with the mercy of the database company who is giving the database, or every user is on mercy of me because I am running the database in my own server. So both of them are centralized. Now, here in blockchain, these miners are, you don't know. This guy, miner is just a normal computer, assume it like that. Okay, a guy with a computer. So let's say this guy is in Los Angeles, this guy is in maybe Italy, this guy is maybe in Finland, this guy is maybe in India. Okay, now whenever we replace this entire block with this block, the benefit which I can see over here is that there is not one block but many blocks, right? Instead of putting just one block, I am putting these many blocks. In reality, every blockchain has at least lakhs and millions of nodes. Okay. What will these nodes do? If these database data, what which is stored over here, is not stored in one part, but it is stored in each and every miner's machine. So that means if let's say tomorrow this miner tells I will shut down my machine, because of course there are normal humans so they can shut off their machines. Even if he shuts off their machines, there is still three miners left. Even if two of them shut down their machine, still we will have two more miners. So data is still stored in any of their machines. Even if all three of them shuts down their business, still I will have my data secured with this guy, right? So the advantage of blockchain is that if you want to close a blockchain, like if you want to close a database, you just need to go to MongoDB and tell them to shut down your business. I am acquiring, and it's done. Tomorrow, if the government says that, okay, I will no longer allow MongoDB because of some license issue, so I issue a notice to MongoDB and tell them to shut down your business, and we are doomed, right? But here, even since this network is run by local people who are the miners, first thing is that government cannot tell each and every one to close their laptops. And if at least one miner, one node, or one laptop, all three are synonymous for this case, okay. At least if one guy keeps on running, the blockchain will keep on running. You cannot stop a blockchain. That is the biggest advantage. Nobody, your data is secure. Nobody can delete your data. Nobody can abruptly stop your business, and it will keep on running. This is the biggest advantage of blockchain. So if the miners are running in multiple countries, actually it cannot be stopped. If all the miners are running in India, okay, government says that all miners please stop their machine, or they shut off the Indian internet, and it's gone. But if the miners are running in different countries, it is not possible to stop. So a blockchain, if the data is in blockchain, it is said to be immutable because of this reason. So this is the biggest characteristic of blockchain, that it is immutable. The data inside a blockchain cannot be changed because it is already stored in at least some of them. Now you will the first question which should come to your mind is that here we are doing from front end to back end to DB, we are always using some kind of CAD operation. So we need to create something, we need to delete something, we need to edit something, and we need to read something, right? Then if the data is immutable, then how can I do these things? I cannot edit, right? If it is immutable means you cannot change it. But it's not the case. So immutable means no corruption cannot be done. You cannot change the data. Now, how will I change the data? If I need to change the data, I will send a request to all the miners who are active in the blockchain. If the change is legal, logical, then it has to be accepted by all the miners. This mechanism of accepting a change which is going to happen in blockchain is called consensus. Okay. So consensus means all of them agree that yes, this data which is coming into blockchain can be put into the blockchain, can be put inside the blocks. We know what is blocks, right? So if a data needs to go inside a block, or if a data inside a block needs to be changed, it has to be agreed upon by all the miners, or it has to be agreed upon, or it has to be consensus, in consensus. Now, how will it be agreed by all the miners? They may not speak the same language. They may not have the same machine. Someone will have a Linux machine, someone may have a Mac machine, someone will have a Windows machine. So, how will they agree? That is why in a blockchain, when you create a blockchain, there is something also called consensus mechanism or consensus algorithm, which they will agree before they starting the blockchain, that okay, there is some kind of algorithm or some kind of mechanism which we will all agree upon, and if that incoming change from our front end or from our back end, if that incoming change comes inside that consensus mechanism, if our consensus algorithm approves it, then only we will allow that change to go inside the blockchain. Okay. So, no, first advantage which we found is that nobody can change the blockchain data. If you need to change the blockchain data, all the nodes needs to be aligned. You cannot corrupt just one node. So all the nodes have a same copy of the data. So if you need to change the data, all the nodes must agree, they must change the data, and they must again keep a copy with all of them. So you cannot corrupt a single node, you have to corrupt all the nodes, which cannot be possible because there is a consensus algorithm which is predetermined. You cannot bypass that algorithm because you don't have access to those algorithm. That is only reserved for miners. So if your data is false under the consensus algorithm, then only it will be stored in the miners. Okay. Till this part clear? Any questions till now?
No, sir, I was just noting those things.
Yes, yes, no issue. Okay. So this is how a blockchain works. Okay. Now, if okay, now there is a concept of smart contract. Okay. So now what is smart contract? Like what is a normal contract? A contract is in common sense if it comes to your mind. It comes if you have ever purchased a house or a bike or something or anything whenever you purchase something, we make a contract. We make a legal contract in a normal stamp paper. In India, it is done using normal stamp paper where you sign, you get it notarized. There is lot of legal procedure, right? So what is a contract? If I talk about a normal contract, in common sense, it's I can define it like that. It is a set of agreements, a set of rules which both party has to follow, and it is agreed upon. That is what is called a contract. So here also, smart contract is nothing but an agreement between both parties. The first party is our application, the second party is blockchain. It is an agreement between both parties that whatever changes will come through this pipeline, it will have certain guidelines. It will follow certain contract agreements, contract rules. Okay. If it does not follow that contract rule, that will not even go to blockchain. Once it passes our contract rules, then only it will go through our blockchain, and then only the blockchain will run its consensus algorithm, and then only it will save it in our miners databases. Okay. Also, this contract again, when you make a contract, what is the first thing you do? When you sign, everything is done, the contract is ready. When you go to buy a house, you do the first thing is that you make a copy of the contract, keep one copy with you, keep one copy with the seller, so that in future nobody will be in doubt that what was written in the contract. Both should have a copy of the contract. Okay. So here also, whenever we will make a contract with our blockchain, we will of course have a contract. Since we are making the contract, we will anyway have a copy of the contract, and the contract will also be with the blockchain, so that even miners can verify that okay, the contract was this, our consensus agreement allows this, so okay, let's go through it. Otherwise, the blockchain will not allow that change to happen since it is violating the contract. Okay, think of it like contract is a set of rules agreed upon by our application and the blockchain application. Till now clear what is contract?
Yes, yes,
Okay, nothing, no technical stuff till now, just pure common
yes.
sense stuff. Okay. So just understand the concepts first. That is why I said just use your common sense, nothing else, no technical stuff. I will go into technical details later. Okay. So this
Okay.
process of sharing contract with a front end and the blockchain, not front end, I will say our application and the blockchain is called deployment. We have to deploy the contract on blockchain. Only after then the blockchain will start respecting our contract. Okay. Now, what is the transaction in a blockchain? Transaction does not, if I talk about transaction, the first thing which comes to your mind is, of course, sending money. If I send you 5 rupees, you send me 10 rupees, that is a transaction, right? This is the common notion of transaction which we have. In blockchain world or in this Web3 world, blockchain is also called Web3 sometimes. Okay. So in blockchain world,
Okay.
this concept of so basically if I talk about web3, this algorithm, this architecture where you are having a front end back end database, you are self sufficient, this is called web2 algorithm or web2 architecture or web2 environment. Whenever you include blockchain, so that means you are having some part of your application which was previously made, and you are just replacing the database with the blockchain. This new environment with front end, back end, and blockchain, this new environment is called Web3 environment or Web3 instance, whatever, or Web3 architecture. Okay. So in a
Okay.
Web3 architecture, so first thing is that we make a contract, which will be something like I'm calling smart. Okay, these contracts for our Web3 is called smart contracts. Nothing more. Okay, no fancy terms. So these smart contract, let's say it is a small block. Yes. Yes. So these okay, better if I actually it should not be here. It should be here. So now we are removing the database and we are connecting with blockchain. And here I will put SC means smart contract in the picture. Okay. So smart contract is our interface for connecting our entire application with blockchain. And blockchain is knowing our application through smart contract. So smart contract treat of it as a broker in a real estate industry. So if you want to make a contract, when you are buying a house, you need to have a broker. The broker will do a mediator and they will do a relation between both of them and create a contract. Once your contract is ready, you deploy the contract on blockchain. That means the blockchain will now start respecting your contract. It will know, okay, there is a contract, I need to follow these rules. The set of rules written in the contract. Okay. Till now, clear?
Yes.
Okay. If you have any question anytime, just stop me and ask if I'm going too fast. Okay.
Okay. Okay. Okay.
So now let's start with the development. So a smart contract project looks something like this. So a smart contract project, forget about this thing. The structure looks something like this. Okay, this is not a React project. Okay, so don't use
Okay.
those mindset. Keep everything out. Okay,
Okay.
right now for you, you will not create a smart contract from your own. You just need to connect with the smart contract, and then remaining thing will happen. Okay,
Okay.
so a smart contract project. So this particular module or this particular project looks something like this. Okay. Again, some of them are self-made, some of them are you have to create on your own. So the main, I will show you. This is the contract. I use usually, okay, blockchain, you have heard about Bitcoin, Ethereum. These are the
Yes.
cryptocurrencies which you have commonly heard. Okay. Bitcoin, Ethereum, Polygon, or what else? Can you name some cryptocurrencies apart from?
Yes. Do
Okay, correct.
Doji coins
Correct.
and so many are there.
So many are there.
XTCs.
Yes, so many are there. Okay, so many coins are there. Okay,
Yes.
okay. But all the coins, you are naming them as coins. You are not calling them blockchain. So, what is the difference between a coin and a blockchain? That is the first thing to understand. Okay. If I say Bitcoin, Bitcoin is a coin, of course, and it is also a blockchain. Ethereum is a coin and it is also a blockchain.
Blockchain.
But Doge is a coin, but it is not a blockchain. Okay.
Okay.
Sorry, Doge. No, my bad. Doge is also a blockchain. Okay. But for example, GLL, you have worked on GLL tokens, right?
Yes.
Yes. GLL is a coin, but not a blockchain. So why I am telling that? For some cryptocurrencies I am telling that they are both coin and blockchain, but for some cryptocurrencies I am being biased and saying that they are only cryptocurrencies, not blockchain. Why? Because since the evaluation of since the I mean origin of this blockchain technology, the first thing which came into existence was blockchain. Okay, this system of network between miners shared among themselves. This system is called blockchain. This network. So blockchain is a network which I just referred. Blockchain is a network where miners do their work. And if you want to get your data into blockchain in this network, you have to pass it through a smart contract. The miners should know what is the smart contract, so you need to deploy the smart contract, and then they will take care of their algorithm and all, whatever algorithm is there inside this. So, as a developer, you do not need to worry about their consensus algorithm. This is their own algorithm. Okay. So, think of it like you tell them that you tell these guys that save my data, Ram sent to Shyam $5. Save this data somewhere. Okay.
Okay.
So what the miners will do, they have their algorithm. They want that, okay, let's say they are all in Italy and they prefer Italian language. They are anti-English. Said that they don't want to use English. So when you give them that Ram sent to Shyam $5, you are speaking in English, right?
Yes.
They will neither understand, their consensus algorithm is that this is their algorithm. We will save everything in Italian. We will not do anything in English language. Okay. So there should be something, this is the smart contract. There should be something which will translate your English language to their a something language which they will understand. That is the job of smart contract. Okay.
Okay.
And then, if the miners decide that, okay, Ram sent to Shyam $5, if I want to save in Italian or Hebrew, whatever language I want, that again, that is the consensus algorithm. So they have agreed to write this data in Italian language. Okay. Or
Okay.
it is their decision to save this information in a piece of paper, or they want to keep it in a hard disk, or they want to keep in wherever they want. This is
Yes.
their consensus algorithm. We don't need to worry about that. Okay, so the thing is that when this smart contract will ask the miner, okay, after 5 days, okay, send me the data which I ask you to save. The miner will take it out from their piece of paper or hard disk, whatever they want to keep. I don't care, based on their algorithm. They will give that information. They should be able to give that information to smart contract back. And my job is done. I am just sending, I as an application owner, I am sending the data to smart contract. I'm getting the data from smart contract. My job is done. I'm happy. What the miners are doing with my data, how they are storing it, that is the consensus algorithm. Okay, so we don't need
Okay.
to worry about that consensus algorithm because it is the miner's responsibility, not my responsibility. Okay, now, so when blockchain started, initially there was this blockchain. There was no cryptocurrencies when the era of blockchain began. So Bitcoin made their own blockchain, Ethereum made their own blockchain, Doge made their own blockchain, but still the cryptocurrencies were not born. So why was cryptocurrency was even invented? Why do I need a cryptocurrency? We already have a blockchain, right? This entire architecture can work till now. There is no need of any cryptocurrency, right? I will send the data, the blockchain will work on consensus algorithm. Nowhere cryptocurrency is used till now.
Yes.
So why was cryptocurrency even invented in the first place? What was the need? So, why was cryptocurrency invented is that because now the problem began when the miner started doing this work, front end was giving task to smart contract giving the work. So till now, earlier the database companies used to make huge amount of money with the subscription. Now you remove the database company and they started using this free system where I am just sending it, miners are saving in a very secure way and I am able to run my application without database. So front end is of course saving hell lot of money, but miners now started feeling the pain that they are doing all the work, but nobody is paying them anything. They are doing on its own, free. So
Yes.
now they said that no, we also need to have something as money. So what they started is that they said that from now on, whatever CRUD operation you will do, CRUD operation in blockchain is equal to transaction. Every CRUD operation is a transaction. Transaction is not only that you are sending money from Ram to Shyam. The transaction word will be used for CRUD operation. Every operation will be termed as a transaction. So whenever you are doing any CRUD operation, the miners have to do certain amount of task. Now they are telling that we will not do this task for free. Every transaction which you want to go through blockchain need to have some kind of money associated with it. What is the money? That money is called gas. So miners need gas for every transaction. And it will be again shared among themselves based on their consensus algorithm. We don't care about that. So our task is just to pay gas to miners, and the miners will share it amongst themselves based on some algorithms. Okay. Now the question is that these guys are normal guys, normal humans. How will I send them money? Will I have everyone's bank account? Not possible.
Mm,
Can it be possible that there is only one bank account of the entire blockchain where everybody is sending money? Again, not
no.
possible. Because anyway, one day of my, so that bank account, everyone will have access. So one day, one miner will empty the bank account and vanish off in some island of Miami. This is possible.
Yes.
So, and also if there is a bank account where huge amount of money is coming from multiple applications, because this is my application, there will be
Y-
your application also, which is also
Yes.
trying to connect to blockchain. So there will be thousands of applications connecting to a single blockchain. So that means the miners are making huge amount of money. Now, if there is a centralized bank, income tax will come. It is not possible. It is simply not possible.
Yes.
And if I just stop that bank account, the miners will, of course, stop working. If I freeze the bank account, let's say tomorrow CBI comes and freezes the bank account, of course, no miner will get money. All the miners will shut down. The entire blockchain shuts down.
Yes.
Not a sustainable mechanism. Okay. So there was a need of some kind of payment method which is bypassing banks. Banks deal with fiat currency. Fiat means your Indian rupees, dollar, euro, wherever there is a note, a bank note which you can keep in your pocket is involved, that is called fiat currency, which you can hold in your hands and give it to someone. Right. So now the concept of cryptocurrency was born because fiat currency can no more be used in this scenario. You need to have some kind of payment mechanism which is not going through any bank. But fiat needs to be gone through any fiat currency concept is clear. What is a fiat currency?
Yes. A physical money that I can hold.
Yes, any physical money which you can hold with your own fingers, that is called a fiat currency. If there is a note associated with that currency, it is a fiat. As simple as that.
Yes.
So China uses yuan, they have a currency of their own. D- Japan uses yen, it's a currency on their own. USA uses dollar, everyone has a note associated with it. So if it is a note, it's a fiat. So it is not possible to use fiat currency in this scenario. You understood the reason why.
Yes.
So now there came a need where there should be some other currency which is a false currency, but it is not a fiat currency. So of course it's a false currency. But I can use it for my daily work. So miners started using false currencies. Another term of false is crypto. So they started using false currencies or cryptocurrencies. That is how cryptocurrency was born. Okay. So the blockchain miners said, okay, so we will make a cryptocurrency or token, both are same things. We will make a token which we will accept. That is our currency. So if you need to talk to us, you need to pay us money, means you need to pay us Bitcoin token. If you are using blockchain of Bitcoin. Okay. Clear till
Okay.
now?
Yes, yes.
You cannot pay Ethereum in that case. Since you are using Bitcoin's blockchain, their algorithm, they have agreed that okay, Bitcoin is our central currency, which we will use among ourselves. So Bitcoin token was invented. Similarly, when Ethereum made its own blockchain, Ethereum said, okay, our token will be Ethereum, ETH token. When Doge made their own blockchain, they said DOGE will be our token. So if I talk in a very simple way in one line, every blockchain can be treated as a country of its own with the citizens as miners and they
With
have
their own
their own
currency.
currency.
Yes.
They will not respect any other currencies. Even if they respect, there will be an exchange rate. Similar way, like our world works. USA uses dollar, India uses Indian rupees. Both are using their own currencies. They will not accept dollar, neither will US accept Indian rupees. You cannot buy a samosa in India with dollar, right?
Yes.
But you have
I
to
have to
convert it
exchange.
to Indian rupees following certain conversion mechanism, then you can use it.
Yes.
But in India, by default, you cannot use dollar. You have to use Indian rupees. Similarly, in this blockchain, so you can treat every blockchain as a country of its own. So in the blockchain ecosystem, the token which can circulate is their native token. Now the concept of native tokens come. What is native token? Native token is that token in the blockchain which the miners has agreed upon. That it will be their mode of gas. So native token is that currency which can be used to pay gas to the miners. Clear?
Yes. One question. If one miner can one miner do mine blocks in two places, or one miner have to mine at one place, like one network?
Mm, he can. If he is a
Okay.
part of another blockchain also, let's say there is another blockchain. Let's say this is another blockchain.
Hmm.
This is, let's say, Ethereum blockchain. This is Ethereum blockchain, and this one was, let's assume, this is my Bitcoin blockchain. So this miner can become a node in Ethereum blockchain also, not a problem.
Okay.
But Ethereum will have its own consensus algorithm. Blockchain will have its own consensus algorithm. When he wants to talk to blockchain, he has to talk in blockchain's algorithm or blockchain's Bitcoin's language. When it talks to Ethereum, it has to talk with their algorithm. And both of
Okay.
them will be, trust me, different. Okay.
Okay.
So it is like you are doing a job in two companies. Of course, you can.
Okay. 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 Okay.
But in
Okay.
the first company, you have to work on their project, written in maybe
Yes.
Java. And in other company, you have to work on their project, maybe written in Python. You cannot work in the second company with Java, right?
Okay.
And you cannot work in the first company with Python. If you have two skills,
Yes.
why not? Right. But both the
Mm-hmm.
companies will work in their own consensus algorithm. So if you are able to support both the consensus algorithm, of course you can be a miner in multiple blockchains.
Okay. So like more networks and then more pressure or load on the device,
Of
miner's
course.
device.
Of course. And
Yes.
both and all the networks is talking in different languages.
Yes.
So if you are a miner, you need to know all of them.
Yes.
Okay. But if you can, of course, why not? If you have that much, if your miner, if the miner has that much skill or that much skill in this case, have computer space, computer capability, computer resources, of course, why not? There are many
Yes.
people in the
Okay.
world who are mining Bitcoin, Ethereum, Dogecoin, everything. They have huge, huge GPUs
Yes.
kept in their rooms, which is using huge amount of electrical resources. If they are able to pay for them, not a problem for anyone, right?
Okay.
Those
Yes.
miners' laptops needs to have consensus algorithm of all the networks they are mining. They need to have, so that means, so for example, if you want, let's say you are as a human bilingual, you know Bengali, you know English. That means in your brain you have the entire vocabulary of Bengali and entire vocabulary of English saved, right?
Yes.
Yes. So if your brain can store multiple languages, of course you can be multilingual. You can learn Italian, you can learn German, you can do whatever, but you need to give that effort. Your brain's capacity needs to expand. Similarly, if
Yes.
you
Yes.
want one laptop to or one computer, minor will be computer in the end. So if you want one computer to run in multiple blockchains, of course it need to have the entire consensus algorithm saved in the hard disk, and it needs to be processed equal to the speed of all the miners.
Yes.
Okay, but it is a good question. So you can be a miner, depends on how much you want to spend and whether it will be worth, because your money will be coming only from the gas. So if you have to do that maths within yourself. So if you are able to generate sufficient amount of money, then it's fine. For example, I will give you one example of a consensus algorithm also. Let's I'll talk about blockchain of Bitcoin. Okay, Bitcoin have an algorithm, consensus algorithm, which is okay. These are just theoretical terms, theoretical things which I'm telling you. It will not be used in your coding ever. Okay, just listen it as a story. So Bitcoin uses proof of work algorithm. Their algorithm is called proof of work, POW. Okay. What is POW? POW is whenever some task come from smart contract, all the miners jump into it. Okay.
Okay.
As soon as they jump into this, now to do that work, their algorithm says, okay, there is a set of puzzles which is randomly generated. So you have to choose which miner actually does the task. Okay. So their algorithm proof of work means whichever miner actually does the task, all the reward goes to that particular miner, and all the other things gets zero. Absolutely zero.
Oh,
This is their algorithm. They have decided upon. They are not sharing the reward equally. They are told that whoever does the work will get all the reward. So of course, the first thing which comes in the mind, whenever there is a work, there is a high competition that all of them will jump in and try to get their work,
yes.
so that whoever can win that race will get the money, the complete money. Now, in order to choose, so your algorithm is actually choosing one of the miner. In order to choose the miner, Bitcoin said, okay, I will give you a sort of entrance exam, a sort of puzzle. Similar way, like in the BC Roy, there were many people who sat for our recruitment. If we gave them an entrance exam, you qualified that exam, that is why you are here. Similarly, the Bitcoin blockchain is giving them a puzzle, a task to solve, a complex mathematical task. Whoever solves that task first gets the right to do this incoming task and own the reward. Okay?
So, like, if someone among these four miners have a high capacity setup, then 90% of the tasks he will do, right?
That is why Bitcoin mining needs high capacity machines. Otherwise, you
Okay.
will not get gas fee. You will not get any reward. You will just be a miner in that network.
Okay. Okay. Okay.
This is why Bitcoin blockchain is not used that frequently nowadays, because this algorithm has the flaw which you just pointed out. This was the
Okay.
biggest flaw. That is why miners started leaving Bitcoin blockchain. Only high powered miners remained in Bitcoin mining. That is why you don't see Bitcoin mining happening in every house every now and then.
Yes.
Because anyway, if you join the network, you can join it. But to win this task, you have to do that complex mathematical puzzle. And to do that, you need to have extremely high GPU, extremely high CPU. Highest of the highest possible. Whoever has the highest will win it.
Yes.
So this is an algorithm called proof of work. This was invented very long back. This is not used nowadays. So this algorithm is still in use in Bitcoin blockchain only. There are other consensus algorithm like Byzantine fault algorithm, then proof of stake algorithm, all these things. Ethereum uses proof of stake algorithm. Okay. Proof of stake means you have, if to become a miner, you have to put some Ethereum in stake with the blockchain. Whoever has the highest Bitcoin, highest Ethereum stake will get the chance of becoming a miner, become the doing the task. And again, he will get all the reward. Again, there is a fault in that because that means the rich guys will buy Ethereum, keep on staking it, and making more money using that.
Yes.
So the poor guys cannot join into the mining. That is why you don't also see Ethereum mining happening now and then. Only the highest, only the richest guy does the Ethereum mining. Also, the reward is also high. Okay, because the reward comes with Ethereum's native token. Reward always comes in the blockchain's native token. Ethereum's native token is ETH. So even if you can make or earn one ETH, that is equal to 2,000 or $3,000 as per the
Mm,
current price.
yes.
So even if you can make one Ethereum in 1 month, your whole month's work is done. Maybe 2, 3 months work is done. You can sleep. Clear? Till now it's clear.
Yes, yes,
So
yes.
similarly, different blockchains uses different algorithm. As a blockchain developer, you don't have to worry and you cannot do anything with that algorithm. You cannot change that. Okay.
Okay.
So that is where cryptocurrencies came into market. That the native token is that blockchain's native token, which is the currency amongst them, which is the gas which is coming. So gas can only and only be paid with the native token because they cannot identify any other token. This is their currency. Similarly, like to buy a samosa in India, you have to pay only with India's native token, which is Indian national rupees. You cannot pay in any other rupees, right? So why now you are clear that what is cryptocurrency, what is native token, and what is blockchain, what is mining algorithm, everything is clear till now, right?
Yes, yes.
Okay. So now what is a non-native token then? Why GLL? In case of GLL, I said okay, it's a token, it's a cryptocurrency, but not a native token or not a blockchain. Why? Because we don't have a blockchain. We are running on XDC blockchain in our case. I'm talking
Okay.
particularly for GLL, giving you as an example. GLL is actually running on XDC blockchain. XDC is another blockchain which is having another set of miners, another set of algorithm. I don't know. Okay, and I don't also want to know. But
Yes.
there is some kind of algorithm also in XDC. So XDC is the blockchain which we are using. We could have used Ethereum, but since our project is sponsored by XDC, we are using XDC blockchain. Okay. Now, so that means I can also, okay, I also said that blockchain is a network. So sometimes during the discussion, I will switch between blockchains and network. Understand that? Okay. Blockchains
Okay.
equal to network, network equal to blockchain. As simple as that. Okay. So our token, our GLL token is a non-native token which is hosted on XDC network. Okay.
Yes.
XDC's native token is XDC itself. XDC has a
Okay.
currency. So if you open GLL, where is it? This is their native token.
Okay.
Okay. And these all are tokens, but not native.
Okay.
Okay. So what we say, sorry. So what is a token? What is a native token and what is a non-native token is that native token is the one which can be treated as a currency amongst the miner. Non-native tokens are also currencies which can circulate in the ecosystem, in the network, but nobody will accept it as a gas.
Okay.
but it can circulate. So of course, if you go to a shop with a dollar note, $5 note in your pocket, nobody is going to put you in jail, right?
Yes.
You cannot use it for buying a samosa, as simple as that. But you can still have the dollar note inside Indian territory. It is highly legal. It is not illegal stuff.
Okay. Okay.
So non-native tokens are cryptocurrencies itself, which may be used in some other purpose, but not for paying something in the blockchain. Gas paying can only be done in native token. Everything else you can do with non-native token. Doesn't matter.
Hmm.
Right. For example, if I give you a simple example, let's say you are there in India, I am there in India. I have, let's say, sunglasses. Okay. You want to
Yes.
take the sunglass from me. Okay. You say that I only have dollar. I say, yes, okay, dollar is fine with me. I will get it exchanged from somewhere. I will give you with $5. I can do it. That is also legal, right?
Yes.
I can, so that means in India itself, you are using cryptocurrency, which is non-native, which is dollar in this case, and you are also getting something from me because I also am in India and I am accepting dollar. So you can take it from me, but don't expect everyone else will do it.
Yes.
So if there are two parties in a blockchain who agrees upon that, okay, I will use dollar for doing something, they can use the cryptocurrency, the non-native cryptocurrency also. But
Okay.
to get it paid to the miners, miners have said that up to if you want to get anything out of us, we will only use our native token. This is the consensus algorithm. So no matter what currency you use within the network amongst yourself, doesn't matter. If you want to touch any miner, you have to pay their native token itself.
Okay.
That means if you want to do any transaction on chain, miner job is to print the transaction on chain. Transaction means card operation, not money transaction.
Yes.
If you want to print any transaction on chain, only for that purpose you have to touch the miner, and only for that purpose you have to pay native token. Okay,
Yes.
why this algorithm was used? Because if non-native tokens started coming into the network, and if there is absolutely no use of using the native token, nobody will use the native token, right?
Yes.
That is why the miners are protecting that and saying that we will only use
Native
native token.
tokens.
So even if you have a non-native token, okay, convert it and get it, give me the native token. That's it. Okay, so similarly, think that non-native token is a US dollar or a euro note in India. And native
Yes.
token is the 10 rupees Indian rupees note, which it is there in your pocket. Clear till now?
Yes. Yes.
Okay, perfect. Now,
One thing,
yes.
uh, like in this blockchain, if
Hmm,
I think this blockchain is XDC networks blockchain, XDC network,
hmm.
Bitcoin is a non-native token in this blockchain.
Exactly.
Okay. Okay. Okay.
But it is a native token in Bitcoin blockchain.
Bitcoin blockchain. Okay.
Correct. Similarly, like dollar is a native token in USA, but not in India.
Yes. Yes.
But it can still exist. It's not illegal.
Okay.
Okay. So now contract, like coming back to contract. So once, how will we identify the contract? So what the front end application will do, front end application will deploy the smart contract, create the smart contract and deploy it on blockchain. As soon as it deploys on our blockchain will give you something like this number.
Okay.
Okay. So once a blockchain accepts your smart contract, so when you send by post something, some letter to me, let's say you send a letter to me. When you send a letter to me, I will receive your letter, but you will not know that I have received my letter, right?
Yes.
Till I send you an acknowledgement that I have received your letter. Thank you so much. Then the
Yes.
transaction is complete, right?
Yes.
So the transaction of sending a letter
is almost similar to transaction of sending a smart contract to blockchain. So when you send a smart contract to blockchain, you have sent it, but you don't know whether blockchain has accepted or there is a network issue or some your internet broke down. You don't know, right?
Yes.
So smart contract will give you an acknowledgement. That acknowledgement is something like this. It looks very similar to 0x, then some alphanumeric number. Okay.
Okay.
This is called a contract address.
Okay.
So that means the blockchain is actually giving you a hint that I have acknowledged your smart contract and you can access it at this address. It is accessible to you at this ad. We are keeping your contract at this address, and this address can never be changed because again it is on blockchain. That means a copy of this contract address is with all the miners.
Hmm.
To change this, all the miners have to agree upon. That means if you want to corrupt, go inside this and corrupt something, if all the miners are, let's say he is in Italy, he is in France, he is in Germany, he is in India, you have to contact each of the person and tell them to corrupt your system. Technically, it's
Okay.
practically not
Im
possible.
Impossible, yes.
Everybody will not listen to you, no matter how powerful you are. Even if Donald Trump says, nobody will listen.
Yes.
People in US will listen, but people in UK or Italy will not listen. As simple as that. So nobody can corrupt. This is the sole reason why blockchain is non-corruptible. But if this data was in this database, Trump will just take the MongoDB CEO in a dinner and just to tell him that, bro, there is one guy in your database, just change this data to this. And he will do it.
Yes, yes.
As
Yes.
simple as that. He will tell its employee that, okay, do it. And the employees will happily do it. But with this mechanism, no powerful person in this person can corrupt your database, no matter how much power he has, because the power lies with the people. This is the concept of decentralization, where the power lies with the miners, with the normal people. That is why blockchain is so unique because you are giving the power back to people.
Yes.
And no, but nobody, no individual person of this collaboration also have power. You have to work as a team or you don't work. No one from this team can one day become powerful enough to control the system. It is not possible, right? Because
Right.
it has to talk to all of them and nobody will listen to him. So this is contract called contract address. So whenever our application wants to talk with our smart contract, which is already deployed to blockchain, it has to talk to this particular address. This particular address will have only your smart contract, nothing else. This is reserved for you.
Hmm.
It is not possible that some other application comes and they also get the same contract address. It is just not possible. It is unique for your smart contract. So every smart contract will have one unique contract address. Okay.
Okay.
Now, how does a smart contract looks that I'm showing you now? So the language of writing the smart contract is not Java or Python, but it is called Solidity. Okay. Now this
Okay.
Solidity comes okay, when Bitcoin came into the market, Bitcoin did not have a concept of smart contract. Bitcoin blockchain cannot actually talk with front-end applications. They can only send money among themselves.
Okay.
Okay. Bitcoin cannot, there is no concept of writing smart contract with Bitcoin. Okay, if there is no smart contract, this world is different, this world is different. There is no connection. Smart contract makes
Hmm.
the connection. Then came Ethereum. Ethereum introduced this concept of smart contract that, okay, why we are only transacting money amongst ourselves. We can also use do the CRUD operation, which is done by all the web applications. We can support it. We can treat it as a transaction. Okay. So Ethereum made a concept of EVM. EVM. Ethereum virtual machine. Okay. So EVM is that virtual machine which needs to be present in all the miners, and that virtual machine has a consensus algorithm which will be following that consensus algorithm. So the miners will have to install that virtual machine EVM in their machines, and then this network will be EVM compatible.
Okay.
Only EVM, only and only EVM compatible machines, no solidity. Only and only EVM compatible networks, no solidity, because solidity was invented by Ethereum.
Yes.
Okay. So when Ethereum made this thing, then many blockchains came and they told, okay, why we will use EVM? We will make a new virtual machine, our own virtual machine. Example, Solana blockchain came. They made their own virtual machine, which is not at all EVM, and they use that virtual machine on their miners. Okay.
Okay.
So of course they will not understand Solidity code. They have their own programming language for Solidity for the smart contract,
Okay.
which is called Rust.
Oh, okay.
Okay. Similarly, there is another blockchain which is called, I think, Algorand. They also do not use Ethereum virtual machine, EVM. Hence, their smart contract have a programming language, I think, called PyLint or something like that.
Okay.
Okay. So right now our focus is that, but in the market 90% of the existing blockchains have actually copied EVM code and made their blockchains.
Okay.
That is why 90% of the blockchains in the market knows Solidity.
Okay.
If you make a contract in Solidity, you just need to deploy it to that EVM compatible blockchain, and they will give you a contract address. As simple as
Contract address.
that. You don't need to worry about everything because they have all copied from Ethereum. XDC is also one such blockchain which has copied from Ethereum. That is why I have written one smart contract with Solidity. I can deploy that same code to Ethereum also, as well as the same code to XDC. No change at all. Okay.
Okay.
Solidity file looks like .sol extension.
Okay.
Okay. So the GLL token which you saw, which you have used, is deployed on XDC network, and this is the tokens code, token smart contract.
Okay.
Okay. It is written with Solidity language. That is why you may not be able to understand it. Maybe if you know Java, you can understand something, but not everything. Like you don't know what is this external, you don't know what is this. So these are all Solidity terms.
Okay.
Okay. This require, you don't know. So these are all Solidity terms. So you don't, 1 minute. Huh?
Yes. Yes.
Okay. So this is how a Solidity smart contract looks. Okay. It is almost similar to like in React, you have talked with methods or routes, which you have
Yes.
made in backend. You have made certain routes or methods or functions in backend, and from your front end, you are just calling them, and they are giving you a JSON output.
Yes.
Right. You don't need to, so the front end do not need to worry what is the backend is written. Front end is only sending you and having an URL
Hmm.
and just talking with that particular method or that particular route, getting the data in JSON. That's it. you don't need to worry what is there happening inside the backend, right? So smart contract is
Yes.
also similar to that. Once you deploy this contract, you get a, what do you get?
Contract address.
You get a contract address. This is your URL, similar to what you use for front end to back end connection. You get a URL, you talk with that URL. Right.
Yes.
So here the URL is your contract address. So similarly, in that URL, there will be many routes.
Yes.
Similarly, in this URL or in this contract address, you will have many functions.
Okay.
So in front end to back end connection, you first connect to that URL, then you point to that route and you get the JSON.
Hmm.
Similarly, here you will connect to this URL or contract address, point to that route or function here, and you will get the output, whatever it's written in this. If there is a return, for example, in this code, there is no return function. But anyway, whatever is written in there, it will happen and it will give the output to the front end. As simple as that. Okay.
Okay.
Now, if we talk about, if I show you our GLL's code, this is our application of Grow Limitless, which you are working on. Nothing new in this, right?
Yes.
Yes. Okay. So in this page, how the blockchain has been integrated in this using this concept. Now I will try to explain you. Okay. So this is the application. If I go to the home page. Okay. First thing it is telling that connect your wallet. Okay. Now what is a wallet? You know what is a wallet, right? It is a combination of
Yes.
public key and private key. Anything which is having a public key and a private key, it is a wallet.
Wallet.
Now, if you have looked closely, every wallet has a public key which looks something like this.
This.
This format is similar to this, right?
Yes.
0x
Yes. Yes.
something. And your wallet address public key is also 0x something, which proves that your wallet is on a Ethereum
Smart.
based network.
Yes.
Okay. So anything which starts with 0x will signify that your contract or your wallet is EVM based. Now you can see that both of them, your wallet address as well as the contract address almost looks same, right? That means
Yes.
they will also behave also similarly. So if you can send money to your wallet and you can store money in your wallet, like I have stored GLL in my wallet, similarly, you can also store money in contract address. Okay?
Okay.
Because it is having a address. Right.
Yes.
So a contract can behave, can be said as an enhanced wallet. A wallet has only money sending and money receiving capacity. Contract also has that as well as some extra piece of code, some extra piece of functions, which was not
Hmm.
present in your normal wallet.
Okay.
Okay. So contract can also behave as a wallet, but contract has some added advantage. It's a pro version of wallet. That's it.
Okay. Okay.
Okay. So let's start. So now you are connecting your wallet. Let's say you connect your wallet over here. Okay. So, yes. Okay. So in this code, in this application, we have used as soon as you click on connect your wallet, you get an interface,
Hmm.
right? So this why this is needed, because first of all, to talk to blockchains or talk to smart contract, you need wallet. Why you need wallet? Because whenever you are telling your smart, you are going through this direction, where is the security? Smart contract can be used by anyone, right? Because it is out there. You have deployed it somewhere.
Yes.
So anyone can use it. It is on public blockchain. This is a public blockchain. It is open, right? So who can use some function like say, in smart contract, we had already closed it, sorry. So for example, let's say you want to use this function called mint, okay?
Mm.
Why will someone whom you do not know it should use it? They should not, right?
Yes.
This address looks like a public key, and public key means it is open to public.
Yes.
So if someone have this public key, if someone somehow gets access, okay, they know that okay, there is a function called mint in this smart contract. So let's try to trigger that function. So similarly, like in front end, if you know the URL and the method name and the route name in this case, you can actually communicate with that, right?
Yes.
But here, what is the security? Here also it should be like this. If you have the URL and the route, which is function, you can actually communicate, right? Start communicating. So any
Yes.
hacker can actually come into the system and get here and start talking like this because he knows this thing, right?
Yes.
So how to stop it? That is why you know you need every transaction which is passing should go through your wallet. Why? Because your wallet has a private key also,
Yes.
which is not available anywhere. Contract has only public key, not private key.
Okay.
Another difference between contract and wallet. This is the sole reason why contracts, being an advanced version of wallet, can never replace wallet altogether. Because wallet has private key. Contract do not have a private key. Okay. So all the transactions which needs to talk to smart contract and then needs to talk to the miners has to pass through your private key. Otherwise, nobody can access it.
Okay.
Okay, that is why in our application, the first step is that connect your wallet so that from a next ongoing transaction, you don't need to connect your wallet. We know which wallet we have to ask for permission.
Yes.
Okay, so whenever you are connecting your wallet and you are actually sending some money to someone, what is happening there? Why this pop-up comes up? This is your
Where?
wallet prompting you to confirm with your private key because MetaMask has your private key. Once you confirm, it will sign the transaction
Yes.
with your private key and then only it will go to blockchain. If you cancel it, blockchain is not even hit.
Okay.
The transaction, this transaction actually stopped here itself. No miner came to know about this. But as soon
Okay.
as you sign the transaction, if you had signed the transaction with your private key, then it will pass through this line and the miners will come to know, okay, we have to send this money to this guy. This is what is happening. Even if you do it MetaMask or the below wallet, the Arcana wallet, which you know,
Yes. Yes.
both are doing the same thing. So wallet has a private key. This is the biggest difference between private wallet and a contract. Okay. Okay. So now coming back to our. So now the first thing is that when you connect your wallet, you need some interface where you are having which wallet you want to connect. We can have MetaMask, we can have something else, we can have
Arcana.
some other wallets also.
Yes.
Okay. And in one wallet, you can have multiple accounts also. Like I have these many accounts.
Yes. Yes.
All of them are having different private key, public key combination. Right.
Yes.
So MetaMask is actually not a wallet. It is like you have watched movies, right? You have
Yes.
downloaded something from your internet, let's say an MP4 player, MP4 file, and then you also need VLC. to play it, right?
Yes.
Without VLC, even if you have an MP4 file, a good high printed MP4 file, you cannot actually watch the movie, right?
Yes.
So MetaMask is like VLC. And these wallets are like my MP4 files.
Okay.
So these files are actually important. If tomorrow I do not want to use VLC, I want to use media player, I can use it.
Okay. Okay.
So MetaMask does not have a private key public key. It is just a player. It's just a video player. So here it's just a wallet player. Your wallets are crucial.
Okay.
You can connect this wallet. Maybe let's say there is also Binance wallet also there. Some wallets are there. You can have to install, so like you install MetaMask. If you want to open this wallet in your Binance wallet, you just need the private key public key. You can connect your Binance wallet with this because it's a player.
Yes.
Extensions are nothing more than players. Okay. Your wallets are super important because they have the private key public key combination. So here, once I'm clicking this, I am telling him to use. Okay, let me disconnect it properly. I am telling him to use MetaMask player. Okay.
Hmm.
Once I click on MetaMask player, it is asking me to connect on which account because it has multiple accounts.
Multiple accounts.
So it is asking me to connect which account for the first time.
Hmm.
I want to connect with this. So I choose this and I click update and I used connect. Once I use connect, it is connecting to that particular wallet. Okay. No other wallet
Yes.
is now connected. Only this wallet is connected. This one.
Hmm.
It is having access to this particular wallet's private key. Okay. Not this will be
Okay.
used for signing, nothing else. Okay. So how are we doing this? This interface and all, we have not created this. There is a third party called uh, Rainbow Kit, which is giving this particular button. If you click this button, this thing will pop up. You can customize this thing.
Okay.
Okay, you can customize this thing. You can just click on this. Everything is happening automatically. This website is not my creation. This is someone else, some third party application. As soon as you connect, it is getting connected.
Hmm.
Okay, everything can be customized. That's it. But these entire application, these entire feature is done by Rainbow Kit. And how we are implementing it? We have just went to docs. Installation guide is there. We will go to manual setup because we are doing it manual. So it is telling to install these packages.
Hmm.
We installed these packages. That is why in our application, front end application, if you go to package.json, you will see this. What is this? Rainbow Kit. Let's see if it is there. Yes, it is here. Next package is WagMe. It is there. WagMe connectors are not WagMe connectors. Yes, WagMe is also installed. These, everything is installed. Okay.
Yes.
So when I made this application, I ran this command and then we have to write this code in a particular page. So wherever we want to put that button. So in our case, we want to put this button in this landing page.
Yes.
So we go to the landing page. That means the code should be in the landing page. This is app.tsx.
Yes.
So if you see the documentation again, it is telling import this line should be the first line. Let me see if this line is at all present here. Yes, this line is present.
Hmm.
Then it has to import this. Everything is done here. This. See, these all are present over here, which is directly coming from there. Okay. This is already given here. We just copy pasted this. Okay. Clear, right?
Yes. Yes.
Okay. Any confusion, any question till now?
No,
No.
I will tell it if have anything.
Okay. Then what it is saying, it is telling to like add chains. Which chain? Okay. Blockchain, network, and chain. They are all
Okay.
same terminology. Okay. So I will
Okay.
use them one against another. Okay.
Okay.
So here I am taking a variable and I am defining XDC. What is XDC? Look, it is coming from WAGMI. What is WAGMI? I installed it over here. Remember?
Yeah.
So it is also coming from this particular package. They are giving
Yes.
access to XDC. When I was developing it, I was also having a test net. Everything they are providing. I don't need to worry about anything. Okay. So I am getting all the chain. There is some configuration files. That is why I said that everything can be customized. Okay.
Hmm.
Again, this configuration file, it is provided over here.
Okay.
Just copy paste. Nothing more. What I changed here in chains, they are giving mainnet, Polygon, Optimism, Arbitrium, Base. These are all name of blockchains.
Yes.
Okay. I am giving only XDC
HTC.
because I am on XDC. So you have to just customize for this. Okay. Nothing more. And then what it is telling me to do? It is telling me your app, whatever your app is this, you have to wrap it around these things.
Hmm.
So this was our app from here to here. This was our app. We wrapped it on these three things. Three things are there.
Agree.
WAGMI provider, query client, Rainbow Kit. WAGMI provider, query client, Rainbow Kit. That's it.
Hmm.
Nothing more. And then here we customize. We change the theme, accent color. We added cool mode. These are all given in this. All this documentation are provided. Customization, themes, right? The custom themes are there.
Ah,
Cool mode is there. Cool mode. Cool mode is what? This thing is cool mode. When you click on this is cool mode.
okay.
No CSS is needed. It is already provided by them. Here you just write cool mode. That's it. So I wrote this cool mode, done, job done. If I remove it, that feature will not be there.
Okay.
Okay. So this is a third party application which we have integrated with our application. Because if I told you to create this entire functionality on your own, it will take months to do this.
Yes.
So we will use this particular. So always try to find some third party applications which you can integrate in your application. There is no point smart work. There is no point in working like a foolish guy. You have to work smartly.
Smartly.
So you don't need to invent a wheel. Wheel has already been invented. You just have to find where the wheel is available, take the wheel, make a car out of it.
Yes.
Nowadays, nobody will pay you if you make a wheel. But if you use the same wheel and make a car, people will pay you lakhs and maybe crores of rupees.
Yes.
So that is what is smart working and foolish working. No, nothing needs to be created from scratch nowadays. Everything is available in the market. Every small components are available in the market. That is why React gives you a powerful thing. In HTML, you cannot have a component. You can have an entire page, but
Hmm.
not individual components inside a page. Right. In React, you can have component. That is why if you need to put one particular component, if you think of that, if that one component is made by someone else, you can just put it there because you can installation is super easy. Just install something like this and whatever needed to be installed for Rainbow Kit, it is getting installed automatically. You don't need to write that entire code on your own. You don't
Hmm.
need to worry about CSS. You don't need to worry about responsiveness, nothing. This particular button is already responsive. See, look at the wallet, it opens now.
Okay.
Understood? It is already responsive. If you open the full screen, it is coming something different.
Hmm.
But if you open in a responsive way, it is something different. If you change the font size to something, let's say iPhone 12 Pro, it will change.
Yes.
So I did not write a single line of code for making it responsive, for making the CSS, for making anything. Just copy paste whatever it is given in their installation guide. Got it?
Yes.
And once this thing is done in my main center page, then I put the connect wallet in the navigation bar, right?
Hmm.
So I will go to the components menu header because sorry, the header section. In the header, what I am having, I am having this button. So what is this button? This button, it should be somewhere at the end. Let's see. Okay. What is the text? It's called connect wallet. Let's say where is connect wallet? Connect. Connect your wallet. Okay. Here, connect button. So connect button is there. This is the connect wallet. Okay. So what is this connect button? Connect button is, let's see, where is the definition of connect button? See, it is coming from Rainbow Kit.
Yes.
Directly, you are just putting that one line. You are just putting this one line. That's it.
Hmm.
And your job is, your button is ready, available on the screen. And once you click, it will start functioning also.
Yes.
Because you configured the app.js, whatever is told. So like here I say show balance equals to 2. These are all given in the documentation. See, add the connect button, import this thing, put this tag, done, job done.
Tag button. Yes.
And then you can do this customization, this model wallet, custom chains, you can add it, add-ons. Okay. So this is why try to implement, if a requirement is given by me or Roy or anyone, try to first think whether there is already a third-party application which is doing that same functionality.
Okay.
If it is there, just incorporate it. It will reduce months of your effort. You just need to worry how to install it, how to get it plugged in your device, in your application. Okay.
Okay.
That because the third-party application have already done their testings and all, so you don't need to worry about their at least testing at all. Everything is present.
Hmm.
Okay. So this is how you get it. So now we got connected. Okay. Now for every page, once you go here, you click on this. What is this? This is a drop down
Hmm.
with all these things. Okay. So how it is done? So if you go to this, what is this page? This is pay page, right? So there should be
Yeah.
a pay named pay. Let's see. Yes, there it is. Pay. Okay. So in this page, there should be a drop down, right? So let's
Hmm.
find this drop down. This is normal HTML code itself. Nothing new over here.
Yes.
Oh, let's see. Senkuto. Yes, this is the select.
Yes.
Okay. What is this select? If you want to see, it is highlighted. Ah, this is select. Select is I used another library. I use another library? Because this bar, this styling and all, you can use normal HTML dropdown also.
Hmm.
But then you have to use a styling for making it look good.
Yes.
So that is why React Select is another third-party library, which is giving you nothing but a simple text box. See, if you search it, look, it is just another library,
Hmm.
this is how you have to implement. You have to yarn at this, and then with React component, you have to import select statement, and then start using that select like this. Okay. Once you use this, call this select function, it will give you a beautiful UI with all the CSS done. This small line is there, this arrow is there, nice and looking arrow is there. Okay.
Yes.
Again, I used another third-party tool. Okay, you can use normal drop down also. Again, I'm saying it's not hard and fast tool, but you have to then work on the CSS also, like you did.
Yes.
Okay. Try to do your work in the least effort possible. Be as much lazy as possible. I love lazy people, trust me. Don't be too much energetic. Try to be as lazy as possible. Get the job done in as lazy way as possible. Okay.
Yes.
So what I am doing in select, I am passing this value. Value means whichever will come here. Okay.
Yes.
I am passing this selected option. So what is this selected option? Selected option is used here. I can see here that this icon is here. So selected icon is here. But this is not a definition. So definition will be somewhere above here. So this is the place where I need to go. Yes. Selected option is here. So it's a use state. That means it's a state variable. So selected option.
Hmm.
A state you are storing something. So something got stored over here.
Yes.
How to understand which function it triggered, which actually stored it over here? It is this function. The function
Hmm.
just beside it. So now I have to go to this. So where is set select option is here? It is over here. Yes, set select option. So it is what is happening whenever we are doing handle change function, whatever we are passing, it is coming inside this. Okay. Now what is handle change? I have to go here. Handle change. So it is in there, select. So whenever we are changing something on this select, we are
Hmm.
changing something, it is doing this handle change function. So what is this handle change function? It is actually taking the input and it is getting the address out of it. Okay.
Okay.
What is this address? Now, this is a fun fact. So what is this address? Address is nothing but these tokens address.
Hmm.
These tokens contract address.
Okay. 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 Okay.
Okay. So on now I have to check that. So this is on change. Okay. But I don't want to see
Hmm.
on change. I want to see what is coming before it's even changing. Okay. So before it is even changing, when this let's say I'm loading this page. I'm going to send crypto. Before I'm selecting it, I can just click it and select it. Before I'm selecting it, it is still having these values.
Hmm.
Right. Even when I do anything, it is still having these values. So how it is bringing? That means before on change, I need to change. Once I click on it, I need to worry about that on change function. Right.
Hmm.
So now I have to check what is the options. The options are the thing which is bringing the options. These are the
Yes.
options in front of you. So options is get token by config, then it is passing something inside it. Okay. By name, I can understand it is passing chain ID.
Hmm.
What is chain?
Blockchain.
Correct. So now another concept comes. What is the ID of a blockchain? Okay.
Hmm.
So in the market, like I said, there is blockchain of Bitcoin, blockchain of Ethereum, in our case, blockchain of XDC. So how will our application knows that which blockchain it has to connect? So it is based on the ID of the blockchain. Every blockchain has a unique ID. It can be seen over in this website. This is a website, I don't know who maintains it, but it is a chain list. Here you will get all the blockchains. Okay, let me start from the beginning. All the blockchains which are currently present in the market. These are all
Oh.
the names of the blockchain. Now you see how many blockchains are there.
Hmm.
These are their native currency.
Okay.
These are their chain IDs. And these are their sample contract addresses.
Oh, like how it starts.
How it starts, correct. So you know that 0x means Filecoin mainnet is copied from which blockchain?
Oh, Phil. FIL.
No,
That's the reference.
this blockchain is copied from which blockchain? Which blockchain gives you this kind of address?
Ethereum.
Yes. So that means this blockchain is also copied from Ethereum.
Okay, okay, okay.
What about this blockchain?
The same. It's also Ethereum.
Now see how many blockchains have copied from Ethereum.
Yes.
That means everyone understands solidity.
Hmm.
Just see at the number of
What is
blockchains in the
all
market.
of
This is
them?
XDC. We are using this one.
Okay.
So our chain ID is 50.
50. Yes.
Okay. Remember this thing, huh? Our chain ID is 50.
Okay.
Okay. See how many blockchains are using Ethereum. See,
Almost all of them.
almost all of them. Now I will also show you exceptions. Let me try to find some. See, everyone is using Ethereum. That is why if you know Solidity, you can work on all of the blockchains.
Hmm.
Everybody works on Solidity. Look at this. No, this is also 0x, sorry. Yes.
Same. Yes.
Mhm. Yes. Now, if I give you example, so very rare websites are there, which is uh, okay. Look, no, this is not so.
No, it's same. Yes. Oh, it's a not this.
Look, this is
Yes.
Ethereum, right?
Hmm.
This is the signer, means the wallet address from which this transaction happened. It is
Yes.
so it is a non-Ethereum based blockchain.
Hmm.
So like this, there are blockchains in the market which are not Ethereum based, but majority of the blockchains are Ethereum based.
And best. Yes.
Okay. And every blockchain has a chain ID, which is different, unique chain ID. Okay. This is how any application will identify the blockchain. Okay.
Yes.
So here, as my name is suggesting, it is taking the blockchain ID.
Hmm.
Okay. What is this chain? Let me see. Chain is called over here. Now, here. Yes. So chain is coming from something called use network. What is use network? It is called here. Use network is an inbuilt feature of WAGME, which I installed during RainbowKit.
Ah,
Remember?
okay. Yes. Yes. Yes.
This is also coming from RainbowKit. I don't need to worry how to get the chain ID. Again, it is done by a third-party application.
Hmm.
I just need to call use network use account and I'm getting it in my page because I need to have these details, this information in my page, right?
Hmm.
Otherwise, how will I code? So I am just using this and I'm getting this chain and then I just use chain.id. I get the ID. Done.
Yes.
Okay. Now, what is this get config by chain? Let me see. This is how the value, the options are getting populated.
Yes.
So if I go to get config by chain, what is it? It is defined in assets token config. Okay. So we'll go to assets token config. Here you can see in this. Okay.
Okay.
Uh, Sorry. Where was I? Pay, right? Yes. So here in token config, I am passing the chain ID.
Hmm.
So in that get token config, where is get token config? Here is get token config. Here I am passing the chain ID
It'll
and
chain
I am
number.
getting token config as output. Okay.
Hmm.
What is token config? Again, it is defined over here. This is token config. Token config gets the info. So that means this is 51. 51 means some other blockchain. Not our.
Okay.
Our blockchain is 50, right?
Yes.
So we'll minimize it. This is our blockchain, 50.
Yes.
So here it is defined. First JSON is, this is JSON, right?
Hmm.
First JSON value is keybase value 1, grow limitless GLL, address. What is this address? Do you identify it?
Yes, Ethereum wallet address.
Correct.
Ethereum network address.
Correct. Ethereum network address. So this is the contract address of this token.
Hmm.
Or I will say this is the token's address in our blockchain. So in our blockchain, once we deployed this token, our miners gave us this as our
Hmm.
address,
Contract address.
as
Yes.
our contract address. So in the blockchain of 50, this address belongs to Grow Limitless.
Hmm.
As simple as that.
Yes.
Okay. Similarly, for the next token, so this is Grow Limitless, GLL. So our first option should be Grow Limitless GLL.
Yes.
Next is XSP token. This is the contract address. Both are different, you can see.
Yes.
But the blockchain is still the same, 50.
Yes.
Next, the third one, again, new contract address came, which is significance for this one.
Yes.
Then the fourth one comes. And then the fifth one comes, XDC.
Hmm.
Now, XDC is the native token, right?
Yes.
So we did not deploy it. It was already deployed by I don't know who, but XDC
Yes.
network people accepts it as a gas fee, right?
Yes.
So if I did not deploy it, how will I have the contract address?
I need to get from them.
It will not have a contract address.
Yes. Oh, okay.
It's null. Okay. It will
Hmm.
not have a contract address. You don't need to talk to it like you talk with other tokens because they already know this token.
Okay.
You don't need to point to a particular contact and tell them that, okay, use this particular token. You don't. This is the default token,
Hmm.
right? So you don't need to have a contact address. If you do not give any contact address, it means you are talking to XDC.
Okay. The mainnet.
Yes, that means you are talking to that particular cryptocurrency. You are
Hmm.
talking about that, about XDC, because you did not pass any pointer. So default pointer. Right.
Okay.
So if you have dollar, euro, everything in your pocket, if someone says you 5 and you are standing in India, that means by
Hmm.
default it is Indian rupees. 5 rupees he is telling. He is not telling $5.
Yes.
Right. But if he mentions that $5, then it makes sense. Okay, that means he do not want Indian rupees. He wants only $5.
Yes.
But if he says 5, the price of this samosa is 5.
Rupees.
Of course, you will pay in rupees, right? You will not ask him that 5 what?
Hmm.
People will call you fool if you ask that question.
Yes.
So this is the default currency. This is the native currency. You will pay in the native currency that time. So if the address is null, that means you are talking to XDC. If the
Yes.
address is something else, that means you are talking to that particular token. Clear?
Clear.
Perfect. So now we have this value. We put this thing, do this, and then we click on transfer. Now what
Hmm.
is happening in transfer button? So of course, how to find it? There should be a button called transfer somewhere else. Amount to transfer somewhere else. Yes, button. There is a
Click on.
button called transfer. On click, this function is getting hit. Okay.
Hmm.
Okay. Let me see where is this function. So it is stuck here. What it is doing? It is doing prevent default, whatever it's by default. If validate is going on now. Await. This is the main function which is being called. This thing. What
Hmm.
is this? Payment helper, and then it is keep giving on dot transfer. So payment helper dot transfer. So if I just bring it here, you can understand. Payment helpers dot transfer. What is payment helper?
Uh,
Go to definition.
hmm.
Okay. Payment helper is again a use state. So it's a state variable which is done by something payment. Okay. Payment helper. Yes, I can see here. Payment helper dot initialize. But no, we have to go to the definition. Is there any definition? Payment helper. Yes, there is a definition of payment helper. Yes, here.
Hmm.
Payment helper is there, which is in components payment helper section. Okay. So go to components, payment helper. It should be there. Yes, it is here. Payment helper section. And then what we are doing? What is this? Okay. And then what? Hmm, yeah, sorry. And then what we are doing? We are doing payment helper. No, where is the transfer function? Yes, payment helper dot transfer. So we are calling the dot transfer function,
Hmm.
passing it amount, which we gave over here,
Yes.
and target ID. Now, what is this target ID? Target ID is this particular value.
Yes, whoever I want to send.
So I am just passing these two, as simple as
Hmm.
that. Okay. So now go to payment helper transfer. What is the transfer function? Here is the transfer function. Okay. And it is taking amount as well as target and something
Hmm.
called false. We'll come over this later on. Okay. So what it is doing with these two, it is creating this line. What is this? It is creating a provider. What is this get provider? If I check, go to definition. This is get provider. Where is get provider? In utils, FB utils. Okay. If I go to utils, FB utils, yes, here it is. There should be something called get provider. Yes, here it is.
Hmm.
Okay, so what it is doing in get provider? It is doing a try where it is implementing this particular line, window Arcana provider. Arcana is again a third party application who is giving us this functionality.
Yes.
Without even an MetaMask or something, you will have an email and you can have a wallet. Okay, so I did not made this functionality. This was given by Arcana. So I put Arcana inside of this Rainbow Kit.
Hmm.
Okay. So again, in Arcana document is written. So you have to install some things, whatever. But you have to write this line. Arcana provider request, Ethereum request. This is an again Ethereum stuff. Nothing to
Yeah.
understand or know this thing. This is just a what do you say? Memorizing stuff.
Hmm.
This is for Arcana. So we have here two options. One is Arcana and one is other wallet. Okay.
Hmm.
So our other wallet is written in the catch. So if Arcana is not provided, we will talk with the other wallet. If Arcana is provided, we will click on the other wallet in the Arcana. Okay.
Hmm.
So if you use Arcana, you write this line. If you use other wallet, you write this line.
Fine.
Nothing to
Okay.
understand why. You have to memorize or
Okay.
copy paste. Okay. Next is okay. One more thing you have to do is you have to import ethers.
Hmm.
Already import. This is again given in the package.json. Where is package.json? Yes, here. Here we have ethers.
Yes.
Ethers 5.7 version we are using. So ethers.js is again another third-party application which will help our application talk with Ethereum-based blockchains.
Hmm.
In our case, which is XDC. So if you want to talk with any Ethereum-based blockchains, the process is exactly the same.
Okay.
Okay.
Hmm.
Only thing is that if you want to talk to any other blockchain, you go to the where were we? Here token config. Like here it is for 50. Here it is for some other blockchain 51. I don't know which one is it.
Hmm.
It is 97, some other blockchain. Okay.
Okay.
So if you want to integrate another blockchain, just add this and connect. That's it, done. No need of changing any code. It is made in such a way. Okay.
Hmm.
So if you implement Ethers, your code is compatible with all kind of Ethereum blockchains now. I did not write a single line of code. I just imported Ethers and just put one line of code over here.
Hmm.
Next is that I will put this. If this is not imported in this page, they will throw error. Okay.
Okay.
Next line is I am creating a provider object. Again, it is coming from Ethers. What is Ethers? Here.
Yes.
Okay. Again, nothing to understand why. It is just you have to memorize, put this line. And in case of Arcana, again, you are making a provider like this. So there are only two lines. One is here and one is here. Both looks same. Few things are here. Arcana came, here Ethereum came. Everything else looks exactly same. Again, for the second line, as you can see, Ethers provider, everything is same, except that here it is Windows.Ethereum, here it is Arcana. That's it.
Yes.
Okay. So from here, you get the provider object. Okay. So now what will you do? Again, going back here. Sorry, we were here, na? Transfer. Payment helper transfer function, right?
Hmm.
We're trying to understand that. Okay, transfer function. This line is clear. So it is making the provider object. That means it is understanding whether you are having Arcana or MetaMask.
Yes.
So now it is clear that, okay, now you are connecting to, in our case, it is connected to, let's say, MetaMask. So here the catch actually ran.
Hmm.
Okay. And this gave us our provider.
Yes.
So now our provider object knows that, okay, MetaMask is connected. What next? Next is signer.
Signer.
Signing is, I told you, private key. Signing with the private key.
Yes. Wallet address.
Wallet address. Okay. Wallet address, no. Wallet address is public key. Wallet's private key is needed for signing.
Okay.
Public key is your email address. You will not use your email address for signing, right? You will use your
Yeah.
password for signing. Remember that video.
Okay. Okay. Okay.
So signing will be done something which is only in your possession. Otherwise, I will also sign with your wallet, right?
Hmm. Hmm. Hmm.
Then I can fraud you. So
Yes.
signing, now the provider, which is now knows that it is MetaMask. So it is trying to get the signer, which means this is an inbuilt function in this. If you just write this, it will take your private key now from MetaMask because it knows the MetaMask is connected.
Connected.
Okay. So here in this step, it knows MetaMask or Arcana, what is connected, right?
Hmm.
And then it will go to that here. It will go to MetaMask or Arcana and get the private key signer.
Hmm.
Okay. In address. Next is that till now I get the private key. Now signer.get address. This is giving me the public key,
Okay.
which is the wallet address. As simple as.
Yes. Yes.
So
Yes.
address will be this one itself. So you should
Hmm.
have this value in the address. You can console log this and check also. It should give exactly this value.
Okay.
Okay. If it is not, then it is not connection problem. There is some connection problem. Disconnect and try to connect it properly.
Okay.
Okay. Basically, this address, it should be present. This address should be there in address. Okay.
Hmm.
Now what I am doing, I am creating a token object. Okay. But this is not used anywhere because it is like, so let's ignore this for now. Okay. Now what I am doing, this is Ethereum amount, a constant object. What we are doing, we are getting amount, right? We are getting the amount from the front end from
Hmm.
this, but this is the amount, right? 100. Okay. Again, here also you don't need to worry on why it is done. Ethereum has to, I mean, the smart contract in Solidity cannot read 100. Okay.
Hmm.
it has to be converted in an Ethereum way. For that, ethers, util, parse unit, whatever, just pass this amount, and this function, when it runs, it will give you something which again you cannot understand, but Solidity will understand. This is a way
Yeah.
of encrypting the amount in an Ethereum way. Okay.
Okay.
So in this step, we convert the amount which is coming from the text box to Ethereum understandable amount.
Hmm.
Okay. Again, don't need to understand why this function, what are these function doing. You can just copy paste this. Okay. Next, we are creating an object, whatever, and we are doing what is this? Create contract object. Okay. So let's see what is this now. Okay. This is coming from again FB utils, this
Hmm.
page. Okay. But it is create contract object, not get provided this time. So create contract object, where is it? Here. Here is the definition of create contract object. Okay. What we are doing over here, again, it's a try and a catch. You can see the same functionality is written both in try and catch. Only with the exception, again, Arcana, and here it is normal, not Arcana, MetaMask.
Yes.
Okay. So since we are connected with MetaMask, so of course the catch function will run.
Hmm.
Okay. Are we passing anything inside? No, there is no input parameter. Okay. So what it is giving me, it is again writing this thing, then these things. These two again you have to just memorize, nothing else.
Yes.
Copy paste. There is no understanding over here. Okay. Here it in this line it is creating the network. That means it is understanding which blockchain it is connected in this particular line. Okay.
Hmm. Hmm.
Then it is getting the signer. It is again taking
Signer.
the private key.
Private key.
Okay. Now what it is doing, it is creating Ether's contract object. Now an contract object is being created where three items are being passed. Okay. So now it is actually going to talk with the contract which we have created with the Solidity. Okay.
Okay.
So now what it is doing, it is first getting this get config by chain network.chain ID. Of course, this means 50 for our case,
Hmm. Hmm.
right? And then it is taking phone link address, something like this. So let's go into this. What is this get config by chain stuff? Let's go into the definition. Okay, it is given in .config file. Okay, let's go to .config file. This is .config file. So here we are using get config by chain, where we are passing the network ID,
Hmm.
where we are passing the network ID or the chain, and it
Chain.
will give me some output based on this chain, right?
Yes.
So let me see what is this now, network config. If we go down here, this is the network config, and this you have to, it will take only for that particular chain which is inputted. So it will give you only for that 50 which is written here. This particular JSON, it will be the out
Okay.
because you passed 50. If you passed 51, then this will be your JSON output. Okay.
Okay.
And you are not stopping here. You are outputting, and then you are using only phone link address, not anything else.
Hmm.
So that means from this, you are filtering out phone link address.
Address.
Since it is a JSON, it will take the value, key value
Hmm.
pair, right? So phone link address means the output will be only this thing. So the output of this line is this,
Hmm.
right?
Yes.
So you are pointing to what? You are pointing to the token contract address now.
Yes.
So your code is now looking into that particular blockchain, and now it is looking in that particular function, that particular URL. Remember here I referred to Sometimes I refer this as URL also because you were talking with URL using backend.
Yes.
So here you got the URL now. This is your front end. I mean, sorry, this is your front end. Now it is talking with smart contract.
Hmm.
So now instead of URL to backend, now it is having the URL of smart contract. Correct?
Hmm.
So now we know what is the URL. Now what we need in backend, what else you needed? You needed the route name, right? Which route you have to connect. You had many route, right?
Yes.
So you need to know which route you have to connect in backend.
Hmm.
You made the same route like user with get and post, right?
Yes.
You made many more routes as well, like the default route, the route with ID, column ID, whatever. You made
Hmm.
many routes, but you need only to talk with one particular route. So
Yes.
similarly, here now we got the URL. Now we need the route address. So what was the equivalent of route address over here? It was the function name. What was the equivalent of route address?
Function. Yes.
So here we do not have routes. Here we have functions. So now
Function.
you need the function name also, where you need to connect. Okay. Let's see
Hmm.
how we get it. So we got the contract address now. URL got
Hmm.
it. What else we need? We need some kind of
Connect.
API. What is this
Oh,
dot API? Let's see. It is coming from here. So it is an artifacts. Let me go to that folder. Artifacts, contracts. I'm just going through this path, nothing more.
yes.
Phone link.sol, phone link.json here. Here, what we are doing? Sorry. Where were we? No, we were in view. It's not create contract. Yes, sorry. So
Yes.
here we are passing dot API. Okay.
Hmm.
So if we go in that part and we click ABI, yes, here ABI. Line number 5. Here. So again, this is a JSON, as you can see, as the
Yes.
extension also it is a JSON. So it should
Hmm.
have a key value pair. So if I put the key as ABI, what should I get after the semicolon? Whatever is present, it will come.
Yes.
So I will get this entire thing as output. Okay.
Okay.
Again, this is this, but so we got this file from a folder called artifacts, which is having everything.
Hmm.
This, the smart contract developer who makes it will provide you. You will not create it. You will just use it. Okay.
Okay.
So the smart contract, whoever will code the Solidity file will give you two things. One is the contract address, which you are putting it in config or wherever you want. One is the contract address and one is ABI.
Yes.
Okay. Or he will give you an artifact folder itself and you can link it to that ABI using this.
Hmm.
Okay. So instead of if he gives you only this file, that will also work. Because
Okay.
then you are using this. You don't need all of this. Right. But some
Hmm.
developer, smart contract developer may give you only the artifacts folder. So you have to use it like this. From artifacts, you have to take that JSON file out and you have to just call the ABI file. Okay.
Yes.
Okay. So three things are needed for a contract in front end. One is the contract address, ABI, and private key.
Private key.
Created it over here, signer.
Hmm.
Okay. As soon as you does your smart contract is now pointing to the smart contract wallet address, smart contract address.
Hmm.
It has all the authorization because it is having the private key also.
Okay.
Okay. It now knows who is talking to what. Okay. Now all we need is the function name. Okay.
Hmm.
So till now it's clear. So so in this object, we get the contract object ready. Okay.
Hmm.
Now to talk to a method, Or let me open the exact smart contract which it is pointing to. This you need not know because I am the Solidity developer, so I know where the code is. You don't need to worry about this. I'm just showing you the Solidity file over here. So this is the contract which he is talking to. This is the contract address, and now what he is doing in this line, where he is using this contract object. He is using this contract object here, and he is trying to use dot. This is how you talk to method or you talk to functions. In front end, in with when we are talking with back end, you had to use that fetch. Remember, fetch inside fetch, write that.
Yes.
Then you have to write post method. Then in the body, you have to pass everything. Here, nothing is needed. You just do a dot, the function name, and pass whatever you want to pass in the body. So in the Solidity, there should be a function called fetch primary wallet address, which will input only one thing. So let's see if there is the fetch primary wallet address. Here it is. Okay, which will take only one input. Okay. So if you remember, this target is nothing but whatever we are giving over here. This was the target which we started with. So here it's what is it? It's an email address. Right. So our target is an email address. Here we till now it is email address. So here also we are passing email address. Okay. And what it is doing something and it is returning a wallet. You don't need to worry about this because I'm not expecting you to write Solidity code. It is returning a wallet. That means it is giving you a wallet address. That means who is this Tathagat.Saha? What is the, so that means when you linked your wallet, I can send you money without knowing your wallet address, right? I can send you money with only your email address, correct?
Yes.
Yes. So, but actually in the backend, money cannot be sent to email address, right? Money has to be sent to a wallet.
Yes.
So I need to know what is the wallet associated with this email address. Or more accurately, what is the primary wallet associated with your email address?
Yes.
Because that now is the concept of primary, you will understand more. Because remember, we had primary, secondary stuff. Where is it? Sender is not connected. Okay. Yes, it will connect to the primary one. If I'm using email address, this is my email address. Email address has only one primary. This is the primary of phone number. So there will be only one. So this should be my output. Okay.
Yes.
So that means someone registered Tathagat Saha. This guy, basically this guy who owns this wallet, already registered Tathagat.Saha earlier. So now, if I put Tathagat.Saha, it is fetching from here and it is returning that particular wallet, which is this. Okay. So as soon as you hit this line, you get the wallet address of your friend. But your friend gave you only email address. Okay. Clear till now?
Yes. Yes.
Okay. Now what will you do with this to object? Where is this to object? Okay, we are passing the target address to 2 because these are the if else something. So I'm not teaching about these things you know anyway. It is like if the 2 length is equal to 0, that means there is no wallet linked. Then what it will do? Validations and all. Okay. So if everything passes, it will come here. It is passing this 2 to this target address variable, nothing more. Okay. Now let's work with the target address variable. So what it is doing? Here it is checking if the data of the selected token address. That means the selected, sorry, we were in this page. Selected tokens address. GLL will have an address, right?
Yes.
Which is given in token config file. We saw that. Here for 50, this is coming, right?
Hmm.
So, where are we here? No. Yes, here. So, if it is not null, that means what? Which token have I selected?
The main token. Oh, not null.
Hmm.
Then the GLL token.
No. Not null.
Yes, if it's not null, then it will be any token
Any of
with
them. Correct, correct. It can be any of these four except HDC.
XTC. Yes.
Yes. So this if will work for all the non-native tokens.
Non-native. I forgot
And
that.
the else of this if will work for the native token. As simple as that.
Mhm.
Okay.
Yes.
Okay. So now what we are doing, we are creating a deadline, nothing, just a variable
Hmm.
dot floor a number. Okay. We are making this transaction valid for 1 hour. After that, it will expire. So if you do not initiate or complete the transaction within 1 hour, it is gone. You have to start again.
Yeah.
Okay. Now what we are doing? We are doing this sign permit stuff. What is the sign permit? It's here. Sign permit is this token address, this thing. So this function, this entire function is sign token.
Hmm.
Okay. It is again getting provider, signer, address. These things are constant. You have already faced this.
Yes.
Token contract. So we are now creating an contract object of the token. To make the contract object, again, you remember there are three things. One is token address, ABI, and something else, right?
Hmm.
So here we are passing the token address, which is anyway the token address coming. ERC20 permit. What is this ERC20 permit? It is again the ABI. Second
Hmm.
object has to be an ABI. So here I am calling ABI like this. Okay. So what it is there? There should be a file called ABI. Let's see if there is a file called ABI. There is a file called ABI.
Yes.
Here I am keeping this. See, here this developer did not give you the entire artifacts. He just gave you this.
Yes.
So again, so I have to point it accordingly. Okay.
Okay.
Passing this and then I'm passing the provider, which is I'm getting from here. Okay.
Hmm.
Now there is a token contact dot again nothing to understand. This needs to be nonce needs to be there, and this will come token contract you are creating nonces and you pass the address. Nonce need to be created after token contract. Okay.
Hmm.
Where will you use nonce? I'm telling you after this. Okay. So now I am creating a domain object where we are having name, version, chain ID, verify contract address. Again, token contract is there. Token contract dot name. Okay. So again, what does it mean? Dot name means in that Solidity file. This is the Solidity file's crumbled output. Okay. You have the
Hmm.
entire Solidity file inside this variable. In the Solidity file, there should be something called name. Correct?
Hmm.
Let's see if in the Solidity file we have something called name on. This is the Solidity file. So do we have something called name? Let's see. Yes, we have something called, this is the name. Okay. It is going inside this Solidity file. So this Solidity file is also linked with these files. Okay.
Hmm.
Inside this function is there. So again, you don't need to worry on this thing. You just need to ask me which function should I call for getting the name. Okay. I will
Okay.
give you the function name. whatever the function name is there, you just put it over here. And the output will be whatever you want. Okay. Chain ID is this. Either you get it like this anyway. Even if you don't take it like this, if you pass it 50 or using the WAGMI, you can also get it. This is how you get chain ID without WAGMI. Okay. If you want to get it from WAGMI, you can just use chain.id also, like I showed you earlier. Okay.
Yes.
Okay. Next is verifying contact address is again token contact address, passing that. Nothing more. Okay. So once I pass all these things, my domain object is created. Okay. And then I am creating a type object that who will have this permit. So owner can have, spender can have, value, nuns, everything is there. Now what I'm creating a value object now where owner, spender, value, nuns, deadline are again passed. Signature I am getting like this, VRS, return this. So if you just, for sign permit, if you just copy this function, just pass these variables differently, your job will be done. You are actually signing the contract. No need to go into the details. You can just copy paste this. Okay. Your output will be the return. Return means you are getting a V and R, S, deadline. You are getting these four things as output. Okay. So think of this, the sign permit is a function. Function means it's like a box which is taking these four things and giving you output four things, another four things. Okay. Now let's see what we are doing with this output. That is our main important thing. So we are passing these four things and we are getting four things output. Out of that, we are taking only the first three things. V, R, and S. We are not taking the deadline. Okay. But this function is giving you four output. Okay. You are just not using the last output. Okay. Now what I am doing, this line I have already told you that amount Ethereum cannot use. That is why you need to convert it to Ethereum compatible amount format.
Yes.
Just copy pasting of that. That's it. Okay. Now what we are doing, we are creating a message hash. Okay. Again, this is a hashing mechanism which we use for Ethereum based blockchains, which is called KEKAC 256. Okay. So if someone asked you what is the hashing algorithm used in Ethereum, it is KEKAC 256. Solidity KEKAC 256. Okay.
Once I let me note.
Yeah. But anyway, no need to again memorize this thing. I mean, understand why it is done like this. Again, it is just like this, where you just have to copy paste the code. Okay.
Okay.
Where it is passing, you are passing the address. So now you are hashing. What you are hashing? You are taking the address, which is nothing but, what is your address? Address is this. That is your public key. Okay. Then what you are doing? You are taking the token address, the selected token address.
Whichever token I select.
Correct. Whichever token you select. Target address. What is target address? The variable which we created over here. That means your friend's wallet address.
Yes.
You put it over here. And what is Ether amount? Ether amount is the amount which needs to be sent. So now I have all these four data. I hash it. Hash it means to merge everything together and encrypt it. Okay. But for hashing it, again, you need to pass something like these. What is this? These are Solidity data types. Because this is an address, you have to pass it address. Since this is also a type of address, you have to pass it address. Since this is also a type of address, friend's wallet address, you have to pass an address. And if you pass something amount, which is Ethereum compatible amount version, it is called uint 256. In JavaScript, you have learned about integer, float, these kind of data types, right?
Yes.
But nobody taught you about what is U into 256 because this is not a JavaScript compatible format. This is only Solidity compatible format. Solidity cannot understand integer. It only understand U into 256 stuff. Okay.
Oh,
That is why this line is crucial. It is
okay.
converting your integer coming from your text box first to string and then to this U into 256 format.
Hmm.
That is why here you need to just write U into 56. That's it. So once you have all this thing, you mash it up and you create a hash out of it. This is your message hash.
Hmm.
Okay. Now what you are doing? Now you are making a user signature also. How you are doing? Signer you already know your private key.
Yeah.
You are using your private key to sign message.
Hmm.
Okay. What you are signing? You are signing this message, this hash which you created. You are signing this message and then you are post. You have that means you have a backend somewhere, right? Where you are using CRUD operation. Post is a CRUD operation, remember?
Yes. Yes. Yes.
So you are using post. Here
Hmm.
I could have used fetch also, like you are using in your application. Fetch, then
Hmm.
you are using post and you are passing everything. Instead of that, instead of calling fetch, I used another third party called Axios.
Yes.
Okay, I don't know whether you know about Axios or not, but Axios is another third party which helps you for doing CRUD operations. You cannot
Okay.
also use it. You can use using fetch. You know how to use it. Okay.
Hmm.
But I used fetch. I use Axios because in fetch you have to give header, body, everything. A big chunk of code happens. In Axios you just have Axios.post. Axios itself has this get, post, get all inbuilt.
Okay.
That is why I use it just for simplicity. Okay. Here I am passing my URL. What is my base URL? What is base URL? Let me see. It is here. Base URL comes from env file. So if I
Hmm.
open my env file, there should be something called next public backend base URL, something like this.
Yes.
So let me open my env file. There should be something called next public backend base URL,
Hmm.
which is this.
Hmm.
So instead of hard coding it, if I write it here, my advantage is that if tomorrow I changes my port, I don't need to go into my file, find where I am using Axios, change it over there. No, just go to .env file, change it from 500 to 4. Done.
Yes.
Understood. That is why using .env file is actually a smart way of working.
Hmm.
Okay, so instead of finding this particular line in this particular page, I just go to .env, change it, go to sleep. Done. Job done. Okay, so here what I'm doing this. So in this part, I'm getting this local host, this,
Hmm.
then API, TXN, send money gaslet. So there should be some, this is a route and this is the
Hmm.
URL. Okay,
Okay. Okay.
this
Okay.
is
Okay.
this is the body.
Yes.
So if you use Axios, it is this much easy. You just need URL, route, and body passed like this. You don't need to write anything like body colon this, then header
Okay.
colon this, method colon post. Nothing needs to be written. That is why I prefer using Axios. Again, third party application up to your choice.
Hmm.
Okay. Now, so first let us go to this backend code of this particular route. Okay. So where is the backend? Here is the backend. Okay. So again, there will be server.js. Go to server.js. Okay. This code you can understand. It's simple Node.js backend, right?
Yes.
Okay. So these are the routes. So I have created three routes. One, two, three. As simple as that. Three routes. Okay. Now in your code, you wrote the route function also inside. Instead of that, I wrote it inside this. Okay.
Hmm.
So API/TXM. Why I'm going here? Because my route starts with API/TXM.
TXN.
but I'm not able to find this. The remaining route is not present. At least I got the first route. Okay. So now maybe the remaining route is inside this. I don't know. Let's see. Okay. So where is it definition? Here is the definition. And it is under routes folder, transaction route. So there should be a folder called routes
Hmm.
and there should be transaction routes. Okay. I got it. I got till this folder. Okay. Now what is the route? Now the route is needed is send money
Same.
gasless.
Yes.
So there should be something called send money gasless route. Let me search it. Here. So what we are doing? We are doing a post method here. Now you know this thing you have already done. Request response, you getting it from the request.body, the inputs, and then working on it, right?
Yes.
So what we are doing here, we are passing it as a body. I told you body you don't need to write, just pass. If you don't pass, there is no body. So here body you always pass what? JSON.
Yes.
So here I made the JSON. Amount I am passing, amount, token I am passing, sender, address, receiver is this. So I am passing these variables. Target, currency, VRS, which we got earlier, th- and the signatures, everything. Whatever, these all things we have created in the before steps. Okay.
Yes.
Now I am passing it. Same thing. I'm getting it from request.body. You know this thing. You have done backend. You know how to call from request.body. Okay. Now what I am doing here is also I am creating token contract. Token contract again. Contract object needs three things: token address, ABI, and a signer. Token contract address I'm getting from here. ERC, the ABI. ABI I'm getting from the ABI folder. We are already
Yes.
using it. Okay. ABI I got. Next is the signer. Who will give me the signer?
The private wallet address is the signer.
No. Yes, correct. So from where I got signer, see, here is a fun fact. The signer is getting created over here. Okay. What it is doing, it is taking the private key. Where is the private key kept? It is kept in a dot secret file. So there should be a dot secret file. Here I should have the private key.
Okay.
Okay. So I took the private key. Now I don't know if this is the private key of my wallet. I don't know. This is just a
Yeah.
private. Okay. Now once I have it, I get the signer. Okay. So this is the signer now. So remember now, this is not the private key of the sender. It is not the private key. It cannot be, it may not be the private key of this, right? Because I'm hard coding the private key over here in the dot secret file. So now the signer becomes this guy. Not the signer which came from here.
Like both are same but different.
No, both are not same. That is what I'm saying. Okay, let me check the private key of this since I use this one itself. If I try the account details, let me see if both are same. It starts with 6D0B.
Yes.
Is it same?
No, different.
Different. So there is no concept of similarity over here. So now what happened? Initially, you did the signing using your this wallet, right? You did all the signers till now, but right now the signer changed. This is some other wallet, right?
Yes.
Exactly some other wallet. So now the signer changed. So the signer is this particular wallet which is given in our backend, which is hard coded in our backend. Okay. Okay. So now what is happening? This is the signer now. Now Ether amount. This is anyway coming from Ethereum, right? This is the amount which is coming. Again, what we are doing here, you know that.
Yes.
What is this code doing? Tell me.
converting the integer to the
correct, U into 56 format, whatever format. You don't give a shit about that. Okay. Now what we will do, we are again creating token contract. Token contract we created over here.
hmm,
So now we are connecting to that permit function of the contract. Very similar to like you are talking to an route.
hmm,
So in that smart contract, there is a function called permit, which is taking these outputs, these inputs.
okay.
Okay.
Hmm,
And then you are doing, so whenever you are doing a blockchain transaction, you have to do it dot wait, means it will wait for the transaction to finish.
yes.
Till this step is done, it should not continue the next step because
Hmm,
blockchain transaction needs time. Why it needs time? Because any blockchain transaction means this blockchain transaction.
yes.
So it will pass through the algorithm. Everyone will fight for the task, solve the puzzle, go through the consensus mechanism, and then it will store it and then it will give you acknowledgement. It
Hmm,
takes time. Another disadvantage of blockchain that blockchain is slow because of this reason.
okay.
Database is super fast because they do not have this thing.
Yes.
Okay, that is why this is the negative point of blockchain. Blockchain is slow. And this speed also cannot be increased because you need to pass through this algorithm. This is very crucial for its security of the data, right?
Yes.
So that is why blockchain is slow. So you need to wait. You cannot go on
Hmm,
with the next steps. So wait for this transaction to finish. Once it is finished, so that means you gave all the permissions. This is the permit. You are giving the permits, right?
hmm,
Who is giving the permits? The sender. Who is the
hmm,
sender over here? It is coming from the body. That means this is the sender, the one
hmm,
whose wallet is connected. He is the sender, right? The sender is giving permission. Okay.
hmm.
Point to be noted here: the signer is still not in the picture. He is just silently hiding.
Yes, that's I was going to ask you like who is the signer?
Now the
Like
signer is very clear. The signer is now this guy, the one who is having this private key. That is dot secret.
yes.
So this guy is the signer. Okay.
So basically, who is this? A miner or
This is a wallet which the backend is having. The backend knows of this. This
or
is a
like we
wallet.
don't know
This is the
about that?
wallet's private key.
Yes.
I know it because I developed the code,
Oh, okay.
but you do not know it and you should not know it. This is
Okay.
the wallet which I particularly chose to be the wallet of the backend. I considered backend as my personal guy.
Okay.
Okay. Like this is my wallet.
Hmm.
This may be your wallet.
Hmm.
Similarly, I gave my backend his own wallet.
Okay. 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 Okay.
You do not know it. Where is it? Where it exists? What is this? You do not know it.
Hmm.
It is like I don't know about your wallet. I don't know what is there in your MetaMask, which wallet is there, how much money is there. I don't know that, right? And I should not know it. Correct. Similarly, I am considering backend as a human being, and this backend has a wallet on its own. This is that wallet, and we also should not know what is inside that wallet, right?
Yes, yes.
Okay. So now that wallet is now inside the signer variable. Okay. But
Yes.
till now, when we are giving this permission, we did not use this signer. This signer is only inside this phone link contract, and now we are working with token contract. Token contract do not have the signer. Sorry, token contract has that signer. Correct. Token contract has that signer. So now my backend's private key is now giving permission. Okay.
Hmm. Hmm.
Permission to the sender to start doing transaction to his friend. That means
Yes.
backend is now ready to accept this transaction. Okay. And this permission that backend is going to pass this transaction to smart contract is also, since this is a token contract, it is a smart contract, it is also printed on blockchain now. Once you run this particular line.
Okay.
That now blockchain, the backend wallet has given permission. Everyone knows it now. Clear?
Yes, yes,
Now the next step is that permission is given. Okay. Now the actual transfer needs to happen. The blockchain gave, the backend gave permission. Okay, this transaction can happen on my platform. Everybody knows it. Now the actual transaction should happen also, right? So
yes,
money should go from A to B. So now that message, remember we hashed a message in the front end
yes,
and we passed it as a, where was it? Receiver target currency token. Where was that message pass? Message was passed in user signature.
user signature.
So last output. Okay. So we have that message inside this.
Yes,
Okay. So now what we will do, we will again create the hash because we don't know how to decrypt the hash, right? It is already one-way hash.
yes.
You can only hash something. You cannot dehash something. That is
Hmm.
the beauty of this kind of hashing, the KCAC 256 hashing. That you can only hash, you cannot dehash it. Okay. So now, so
Yes.
if I do not dehash it, then how will I understand? Right. That is the first question which will come to our mind. That if I encrypt something, if I do not decrypt it, then what is the use of encryption?
Hmm.
So here is the use because we are again passing the sender token receiver ether amount in these variables. We will again make the hash in the back end now. Right.
Okay.
So in the
Yes.
beginning, we did the hash in the front end. So if someone has tampered with the front end data, then the hash which is coming from the front end should not match this hash because the data was
Yes.
compared and some other hash was created that time, and now some other hash is getting created, and that is what is being checked over here. We are passing message hash which we are creating over here, and we are passing user signature which we got from front end, and then
Hmm.
we are verifying the message.
Is the same or not?
If both are same, then okay. If both are not same, not okay. Stop it right now. Something is wrong. So this is how encryption protects you.
Hmm. Okay.
You
Yes.
cannot decrypt it. So not even hacker can decrypt your original hash code and try to find what is the incoming stuff. Because your original hash code, if you remember, was created with these four guys.
Yes.
So user, if he manipulates all of these four or any one of these four, he will have a different hash.
Hmm.
And if he manipulates that, then that hash will not match over here. Because we
Yes.
are
The
again creating
transaction.
the hash in our backend. Backend is in our custody. No user can tamper it. Front end is in
Okay.
everyone custody. You can just go to inspect element and you can change stuff, right? Put some
Yes.
debuggers, change some data and push it again. That is why three-layer architecture front end is never directly connected to database. It is always
Yes.
passed through a backend to ensure this security.
Okay.
Okay, so here this step is where we are checking if both the hash are equal. There is anyway no way possible to decrypt the hash. No mathematician can do it.
Hmm.
No hacker can do it. So the only way to use your hash thing is to create another hash and try to check if both the hashes are exactly same. If it is same, then recovered. The signer has been recovered. So now we know that authentication has been done.
Yes.
Confirm. Now do the transaction. Again, what it is doing? It is recovering the signer. Signer. See, here it is doing. If it is failing, then invalid transactions request.
Yes.
Okay. We are converting both to lowercase. We are checking if the sender is the recovered signer or no. So if it is okay, then go to the contract address. What is phone link contract? Phone link contract was the contract which we created with our contract address. And we are hitting the send money method. So let's see what is the send money method. Uh, if there is method called send money, yes, there is a method called send money. And what it is doing, it is taking 1, 2, 3, 4 things as input. Okay. So
Yes.
let's see if we are also passing 4 things. No, yes. No, sorry. Yes, send money. So we are passing 1, 2, 3, 4, 5 things. Okay, let me double check. Here it is passing. I think it's not the latest code. One incoming change. Okay. Okay. So let's see now. We got the latest code. Where is send money? Here is send money. And it is now accepting 1, 2, 3, 4, 5. Now it is okay.
Yes.
Okay. So you have to always check that these number of input parameters should match. Okay. So now we are passing what? Ether amount, token amount, receivers, and then a user sign transaction. Okay. And
Yes.
since it is again a blockchain transaction, we have to wait. Okay. Now let's see what is happening inside this. So what it will do all its stuff, whatever it is done, and it will send the money, this much amount of this much token from this guy to this guy using this signature. And that is what is happening in the Solidity code. No need to worry about that. Just think that this method, if you pass this input, it will do the transaction. That's it. Okay. And then you will take this entire thing inside one variable. Okay. And you will get that output. That's it. So as a front-end developer or a back-end developer, as a non-blockchain developer, you will just call this method, pass the stuff, whatever is output you are getting, you have to wait on that, and then you need to get the transaction hash, chain, etc., etc. So on this, if you just put dot hash, then you should get a transaction hash. If you don't get a transaction hash, that means this variable was not completed. That means something wrong happened with the smart contract method.
Yes.
That means it is not going to blockchain. Now, what is transaction hash? So every blockchain, like I showed you here, multiple blockchains are there. Every blockchain has a blockchain scanner. Okay. So for example, for Ethereum, for XDC, we have a XDC scanner. You can just search it in Google like this. No need to memorize anything. Okay. This is called Blockchain Explorer. Any scanner is called a Blockchain Explorer. Why this is needed is that because this blockchain, like I showed you a diagram, you actually cannot know what is happening inside this, right? Because you are till now you have just connected to a number 50, which was your chain ID, and you did all your work, right?
Yeah.
But you don't actually know what is happening inside that. So you need some kind of explorer which will give a open eye view of this blockchain. That is why every blockchain has a blockchain explorer. In our case, it is this. Okay. So if in this blockchain explorer, if you check for the tokens, again, tokens mean assets, token config, and let's say we are checking for this one, grow limitless. Okay. If you just check where is this address, normal, just search it. You can see there is something in the address. So what you can see, this is the contract creator. Who created this token? This guy created this
Hmm.
token. This guy is, do you see the same similarity?
Okay. Yes.
So that means I did this. This is my creation. Okay.
Hmm.
At transaction, create a transaction hash. What is this? Any transaction. So create is also a transaction, is a CRUD operation.
Hmm.
So any transaction in blockchain is identified by transaction hash. So if you just go to blockchain scanner and from here you get the dot hash, you should get something like this. Again, it will look like a wallet address itself. It starts with 0x. Okay. And if you search
Yes.
it, it will tell you exactly the transaction when it happened. It happened 9 days ago. So I created this token 9 days ago and I kept 90 billion tokens. See, it is open. I did it on my own.
Okay.
You should not know it. It is a hidden thing. But
Hmm.
since it is blockchain, everyone came to know of this. That this guy, but nowhere it is said that this is Tathagat Saha's wallet.
Yes.
This guy, this is the power of blockchain that it also supports anonymity. Whatever you
Hmm.
do in blockchain, you will be known by your public key, not by your name. So it is clearly said 9 days ago, this guy transferred 90 million GLL tokens to this wallet.
Hmm.
Okay, this is minted in block number this, and these many miners have actually approved this.
Okay.
Okay. This transaction happened from here. It is a created transaction. So it's a post method or some kind of operation
Y-
happened. Create
Yes.
operation happened from nothing to this wallet. This grow limitless token was created, and the
Hmm.
gas which I paid was this.
Yes.
Everything is visible on blockchain, and you can explore it using Blockchain Explorer. All you need is a transaction hash. If you do not have a transaction hash, you can check anything. You can check your wallet also. What have been done in my wallet. So if I check my wallet, public key, I'm just checking public key. Okay. I can see till now my transaction has gone through these all transactions happened.
Yes.
And if I click on any other transaction hash, I can see what exactly happened. I transferred this 4 day ago. I transferred this. I think this is your wallet.
Okay.
I just check if this is your public key of any of your wallet.
Okay. Yes. Yes. Let me check. Where is the Chrome? Here it is. It's starting with 027A. I think it's on my other profile. One second. Oh, it's need password. No, that's not my wallet.
Okay. Does your wallet start with 53?
Yes, 53.
Yes. So
That is
look,
the
look in
wallet.
my screen. This is your wallet,
Hmm.
right?
Hmm.
Okay. So that means this is some kind of contract. It is again
Okay.
talking to some kind of contract address. What happened was that due to this interaction, from this is another wallet of mine, from this
Hmm.
to your wallet, 4.975 GLL token was transferred,
Okay.
and I took a commission of 0.025 from
Hmm.
this transfer. That is why you received only 4.9, not 5.
Okay.
Okay, and for this I need to pay 12.5 GUI or
Hmm.
0.000 something XDC.
Okay.
Okay, everything. If I now see, if I go to your wallet, just click it over here. I can see what you have done.
Yes.
So 7 days ago, from here you got 79 tokens.
Hmm.
Then you did this. Then you did this. So whatever you do with your blockchain, whatever you do in blockchain, everything is visible if it is printed on blockchain
Okay.
and visible by anyone. Anyone can see it.
Hmm.
Clear till now?
Yes.
Yes. So from here you can get the transaction hash, and this transaction hash, in our case, we are putting it in my transactions and we are showing it over here. See, this is the transaction hash.
Yes.
If you see the link on the bottom side, you can see if we click on here, it is actually opening XDC scan, that
Hmm.
particular transaction hash, and it is showing you that it is successful
Yes.
and how much gas is given. Everything is transparent. So this transaction is transferred 9 GLL, but in reality, he got 8.95 and I took
Nine five
much as
five.
my commission.
Yes.
Okay. For everyone, for each of the transactions, you are getting it. Okay.
Hmm.
So now your job is that since you, so how did the transaction happen? You don't need to worry. Smart contract did it. Okay.
Yes.
Till now, I never told you that how I am taking the commission.
Hmm.
But I never wrote anywhere to take the commission, but still it happened
Yes.
because it is written in the smart contract. You don't need to.
Okay.
You just need to. So whenever we are working with smart contracts, you have to ask me which methods should I use, what should I pass to that method, and what should I get from that method.
Hmm.
You don't need to know what is happening in the smart contract. So I will tell you my method name is this. Pass me these five things. I will give you something which whose if you put dot hash, you will get the hash key,
Hmm.
transaction hash.
Okay.
And then you want to do a transaction, you need a transaction hash.
Hmm.
That is your acknowledgement. If you have the transaction hash with you, then you can just create a link over here with the transaction hash and you can click it and open it and show it to the whole world.
Okay.
Right. If you do a transaction, you need a transaction hash, which is a proof. Like if you make a payment, you need a receipt.
Hmm.
So transaction hash is like a receipt.
Okay. Okay. Okay.
So you will tell me that give me a method whom I will pass these things, and then you give me a receipt. So I will tell you, okay, you use this method. This method will automatically give you a receipt if you pass it these things.
Hmm.
It will give you the receipt. Now, what you do with your receipt is up to you, not the blockchain developer's job. Now what you do, you create a new transaction of some stuff with the hash.
Hmm.
You pass this thing. Then you new transaction, you save it. What is this save? Save is, what is this save? It is over here. Yes. You are saving the transaction. Save means yes. You are doing a post. Okay, a new transaction. Sorry, my bad. Link gasless, yes. No, make primary gasless. No, where we send money, right?
Hmm.
Send money, yes. So we create a new transaction object and then we are doing transaction wait, okay, and new transaction dot save, okay, but what is the save method? Okay, new transaction. So what is this transaction object? Transaction object is created over here. See, okay,
Hmm.
models dot transaction. Now if we go to models dot transactions, it is connecting to Mongoose. Means uh, Mongoose, okay. Mongoose dot schema. Prisma is not used here. Okay.
Oh. Okay, that's a medium.
Yes. So instead of Prisma, Mongoose is used. But anyway, Mongoose is like MongoDB itself.
Okay.
Okay, it's a like Prisma in like a ready-made Prisma for Mongoose for MongoDB.
Hmm.
Okay. So once you click on transaction.save, it is going nowhere but to the MongoDB. So you are actually saving the transaction. That means transaction has chain, sender, receiver, send to everything you are saving in the database.
Hmm.
And then you are responding back. And this you can console log also.
Yeah.
Success true, transaction has, you are sending it to the front end. That's it. So this is the backend code. Okay, this happened in the backend. Now we were over here, right?
Hmm.
We send this response, we send this axios.post, and in the response, we got what? We got this as a response. So we got a JSON output, right?
Hmm.
Success and transaction hash, right?
Yes.
So we got it inside this. And if the data.success is okay, if we get a success message, which is if we get, where were we? If we get success, if the output is true, so if this output is true, so in JavaScript, you can write it like this, okay?
Hmm.
But if you omit it, by default, it is treated as equal to true,
Okay.
okay? So if bracket this, nothing is there means if you are asking is actually if this is equal to true or not. Both are same thing. If this is
Okay.
true, if you get a transaction has, if the response is true, then just show transfer successful, job done. This is
Yes.
alert. This is the alert which we are using. Again, you have used alert message, right? In your front end.
Yes.
Yes. Again, in our front end, you can see that we are getting this beautiful looking alert, right?
Yes.
Not that ugly looking which we are using. So how to get this beautiful? Again, third party application. Toast. Toast is again
Okay.
React Hot Toast. Again, another third party application. Sorry. If you search over here, anywhere like React Hot Toast, that is what I'm saying. Do not use anything which is like from scratch. Try to get as much. Look, best React host down. Look, if you click it, this is giving you this output. Error is,
Yes.
these are all ready-made mates. You don't need to do anything, right?
Hmm.
You just
Hmm.
need to install something React stuff, something, some import stuff, whatever it is given in the documentation, how to do it. Import and job done. Instead of putting windows.alert, what I did, I put
Yes.
post.success, then some message. And that message will come in a beautiful looking URL.
Hmm.
Easy way to do tough things. Okay, clear till now, right?
Yes. Yes.
Okay, so transfer like this, transfer happen. That is why you get toast successful message. Once this is done, uh, uh, once this is done, again in the pay, the transfer method worked.
Hmm.
Then job done, payment done. Now something else, load balance. The balance is also coming because you need to update this balance also, right? This balance also. This balance need
Yes.
to reduce. So then once done, it will again load the balance. So it will again take the data from the selected one, and now it is giving some kind of reward. But reward, don't worry, reward it's currently off, so it is not working. That's it. Payment helper
Okay.
done. This is how an entire
Hmm.
blockchain system works. Similarly,
Okay.
there are transactions like when you link it now, some blockchain transactions are happening because you are connecting this wallet to this on-chain, right? Similarly, so if you write something on blockchain, we call it printing on-chain. Okay. We are putting the data on chain. Clear till now?
Yes. Yes. Yes.
Similarly, so in anyway, my transaction I showed you what is there. So now browse through the application, see what this is hitting blockchain for sure. Whenever MetaMask is popping off, that means some kind of blockchain interaction is happening.
Hmm.
Okay. And this is the way how a blockchain interaction happen. How contracts, smart contracts come into place, how contract address are always used, ABIs are used, signers are used. These things I have told you. Remember one thing, at the end, who is the final signer? He is the one who is paying gas. Okay.
Okay.
Who is the last? Whenever you can change the signer n number of time, but at the end, when you are pushing your code to blockchain, what you are doing over here, so no, not over here. This is the place where you are pushing in the blockchain, this particular line, where you are actually hitting the method, the smart contract function. This is where you are pushing it in the blockchain. So in this, whatever the last sender is there, whoever is the last sender, as a signer, so the last signer was this signer. That means the blockchain's wallet,
Yes.
not the user wallet, right? Since the last signer was the blockchain's wallet, so the transaction will pass through the blockchain's wallet. So who will pay the gas? The backend's wallet, sorry. So the who will pay the gas? The backend's wallet will pay the gas because it is the last signer.
Hmm.
Understood? This is a core concept. So
Yes.
making so that means the one who is actually doing the transfer from front end is not paying gas. That is why
Hmm.
you do not need to have XDC when you are using a GLL. Although you were
Yes.
using blockchain, I was the one who was
Hmm.
paying the gas. My backend was actually the one who was paying the gas for every of your transaction to Neil or some to your other wallet, whatever happened.
Okay.
That is why for you it looked like gasless.
Hmm.
You were not paying gas, you were just transferring GLL here and there, and everything remained same.
Hmm.
You never paid money to miners, any of the miners, because you never paid gas. Because
Yes.
this backend did that task. This backend is sending the money to miner because he is the last signer. So you are actually changing the signer from front end to back end and then pushing the transaction.
Okay.
This is the trick which was done to make this application gasless.
Hmm.
So for an
So
end,
actually the
yes, go on.
so actually the platform fee is the your
Yes,
commission.
yes, exactly. It is not gas fee.
Uh, yes.
It is not gas fee. It is my platform fee. Since you are using my platform, you are if you do the same transaction from MetaMask, you already have
Hmm.
GLL, right? Try to send your
Yes.
GLL from this, like from here to send. You can do that. Use your other wallet
Hmm.
address. How much GLL you want to send? Let's say 100. Try to
Hmm.
do it. Try to do it. It is asking you to have this much XDC.
Okay.
If you do not have it, you cannot do it.
Hmm.
After this call, try to do it using MetaMask. Okay. You need to pay
Okay.
gas, and like I said in the beginning, gas should always be paid in which token?
Native token.
Native token. And what is the native token of XDC? XDC.
XTC itself.
Yes. So you cannot pay the gas in GLL.
Hmm.
You have to pay the gas in XDC. You do not have XDC, but you have GLL. Try to
Yeah.
transfer GLL using your MetaMask like this.
Hmm.
Your MetaMask will fail. You won't be able to do it because it will ask for
Okay.
gas and you don't have XDC. So you have to again buy XDC, put it in your MetaMask, and then you transfer GLL, right?
Hmm.
Or you use this platform. You don't have to have a GLL, don't have to have XDC because you anyway did not have XDC.
Hmm.
I paid your XDC fees every time you made a transfer. My backend made that transfer possible. You get a
Yes.
gas feeling. You think that there is no money involved. It's completely free. I am just taking your platform fee. That's it
Yes.
in every transaction. That is done in the smart contract. So nobody can even see it because even you as a developer was not able to have access to that.
Yes.
Understood? Clear till now?
Yes. Yes. Yes.
Okay, so now try to explore like I showed you end-to-end flow of this button. Now try to explore the end-to-end flow of this button because this is also opening your pop-up, right?
Yes.
Once you click it, you hit the OTP, your pop-up comes, and then you confirm something, right? Pop-up comes means you are interacting with blockchain. You have started interaction with blockchain.
Yes.
Similarly, when you go to my profile, if there is a secondary wallet also, you can click on it and
Hmm.
make it primary. Again, you are connecting to blockchain. So again, blockchain interaction is happening in the very same way, like I showed you.
Yes.
So this is how blockchain works. Okay.
Hmm.
So that will be all. No need to understand Solidity coding because till as of now, I will take care of that. I will show it to you
Okay.
later on what is Solidity, how to write in Solidity programming language and all. But
Hmm.
as of now, you can do everything using JavaScript, using React, Node.js. That's it. Okay.
Okay.
Okay. So I'm stopping this recording.